screen?
Yes, sir.
Yes, ma'am. Okay. The today topic is power analysis in VLSI. Uh, there are uh, there are several ways to analyze the power. Okay, we can estimate how much power is required. That is one part, and we can understand the power is architectured properly or not. That is one category. And the last category is whether the architectured power is going to the particular blocks is properly or not, and it is optimized. It is working in an optimized way or not. That is the last category. So when it comes to power estimation, the architecture will give its their requirement. Based on that, how many power rails are required, how much power is exactly consumed for this particular chip on the in the worst case scenario and in the best case scenario. Means suppose the particular chip is performing uh, trillions of operations, how much power it will consume. If the chip is performing only one operation, how much power it is required. Like that, so many estimations will be there. Um, so mostly all our current trend chips are power hungry devices. They need so much power, but we have to make them work at a low power. Okay, low power means their consumption is very high, but they'll consume very less voltage. Okay, less voltage they'll consume, but they consume more. You will understand. Okay, that is one point. Another point is if we can't estimate the power properly, if we can't verify the power in the chip properly, and it will lead to a thing called so much heat dissipation, so much uh, so many subsystems will have to work at the same time, right? So they consume more power and they dissipate more heat. So the chip won't survive much longer. Okay, the major drawback when you not carrying the power, the chip life is becoming less and less. Okay, usually any industry, any product-based companies, first they'll estimate the life of the chip, how many years that chip can survive, or how many applications it can serve. Based on that, they'll go with the power. Okay, based on power, they won't go the life. Based on the life of the chip, they'll go to the power things. Okay, that much adaptability is required. So, in the olden days, if I want to make a point like in terms of clock, in the olden days, system on chip may have one or two clocks. Okay, nowadays they are coming with hundreds of different types of clocks. Okay, and olden days, the number of subsystems on a SoC are very less. Nowadays, those are extreme. Those are in more than 10 million, like that. They'll be more than they are in the number of giga. Okay, 10 to the power of 9 number systems are there on the chip. Okay, components are there on the chip. So for all those things, the primary aspect is to they have to connect between them and they have to communicate each other so that there is a need of a power. Okay, uh, so how we are managing the power, okay, uh, how we are optimizing the power is the major point here. Okay, and as many subsystems are increasing on the SoC, that much leakage will be there. Okay, leakage current will be there, so that we need to manage the power thing in the given area for that respective speed. Okay, so why it is so important? Suppose if you see the size if you see a nuclear reactor, it will consume more power. Okay, as well as it will dissipate that much heat. Okay, those are also will work at the some kind of a uh, frequencies. But if you see, when you see the reactor and you see the chip, both one and same in the multiple aspects. Suppose the chip will perform a trillions of operations for the given frequency. So the frequency is nowadays it is in the gigahertz. In the near future, it will become a terahertz also. Okay, so there is no much difference between managing the power in the nuclear reactor and managing the power in the chip. But when it comes to see the sizes of both, chip is very less in size, reactor is very large in size. So don't think like a both power management is different. Okay. Now see, all these chips are in the range of 1 to 10 only. Okay, remaining are is above. But when it comes to from year to from 1970 to 2010, the requirement of the power is increases so much. Okay, because number of subsystems on the chip is increasing. Okay, so all are a battery life, so it depends on life of the battery, portable devices. See, when it comes to these guys, so as I told yesterday, nowadays the Meta or Amazon they are designing their own servers. Okay, so there also power need to be managed, power need to be optimized. Okay, power need to be reliable so much in the respective cost only, in the that minimal cost only. So that, but if you see here, if you see nuclear reactor, that power requirement is different. Requirement is very huge in number, means in megawatts, in gigawatts, the power will be required. But here, components will be in the number of giga, but power is very less. Okay, that's how the trade-off will be. So let's see how to analyze the how to verify the that low power things which we are currently putting in the chip. See, one SOC come up with these kind of things. This is for a sake I kept this picture, but there are more than this. Okay, I will show you.
அண்ணா இருங்க மாத்தி விட்டேன்.
You see here in your laptop, you can see this thing. Okay. So these many memory elements are there. Okay. So in this few more are there. So and this one big large memory is having a I will show you. See input as I told yesterday, all the devices are mapped in a particular address range, right? So for that we power has to go to that particular part and it has to serve, right? And there are so many interrupt requests also there systems. Means one device is working on one thing. Suppose our processor is working on one thing, all of a sudden some request will come. Okay, so processor serving has to shift to the uh, what is that, the other whatever the interrupt came. Okay, for that power has to be managed to that particular whatever the current serving block. Okay, it has to continue the power or it has to switch off the power, all those things like this. So many requests are interrupt requests are there, they can come in between and they serve in between. Okay, like this so many are there. Okay, when it comes to one chip, these many interrupt requests are there. If you see input output devices, so these many are there. Okay, so these many are there. For all these things, we have to manage the power. Uh, yes. Mm. So And most of the process are coming with a multi-core, right? So initial days they have only one core. That one core will serve all the subsystems in the chip. But nowadays they have a multi-core. Now currently they are having a octa-core, a hexa-core, let's say 16 cores. 16 cores in parallel they'll perform the operation so that they consume a power. So if we can't manage or if you can't optimize the power, so the whatever the battery life is there, that will reduce abruptly. Okay. So in order to control these things, we need a several techniques to reduce the power requirement or manage the power, or we have to cut down the some particular power direction, all those things. And see here, if you see here, each CPU has a two power domains. Okay, so entire chip, if you see an entire chip is not working on a one power. Okay, one power domain, not working like a one power value, or it did not consume one power value. So in the chip itself, so many power domains are there. Each domain will work at a different voltages. So that management is extremely difficult. See here, the MP core has three power domains. One is L2 cache RAMs, L2 cache control, debug and trace model. Okay, each this debug and trace mod, whatever the block is there, subsystem, it will work at a different power. Okay, all these L1 caches will work at a different power. All these L2 caches are work at different power. Okay, yeah. What is the various source of power consumption? There is a static power consumption will be there, dynamic power consumption will be there. Okay, so the main source of a static power consumption is leakage current. Okay, because of that leakage current, so much power is consumed. Okay, nowadays they're trying to reduce the leakage current in if there is a million subsystems on a chip. So how to control the leakage current? Now the current trend it is. Recently we worked on a chip like so where power has to be managed on a micro level. Okay, not on the top level. On the subsystem level also power has to be managed. Okay, if you have an interest, please work on the various techniques to control the leakage current. Okay. Nowadays, the component is very small size, right? The channel width is now 3 nanometer. Now currently they are working on 3 nanometer. Okay, so the leakage current and those leakage powers will be more. Okay, when the chip is going to be smaller and smaller, these guys will be these guys will increase in their number, leakage current or leakage power. Okay. So what is dynamic power? Dynamic power means it is like a switching from one power to another power. It can be increased or it can be decreased. Okay. There we need to be a struggled a lot in terms of capacitive loads. Okay. And entire chip is not working on one frequency. From one part of the chip will work on one kind of frequency, another part of chip will work on the another frequency. So the frequency scale also need to be done. Frequency scaling has to be done with a uh, is somehow directly proportional to the power, right? So that so this dynamic power consumption also currently we are facing a lot of problems. So I somehow I'm not a guy who belongs to the physical verification, so that I can't cry on these things. But when it comes to the physical verification, people will cry like anything because of this dynamic power consumption and static power consumption. So we need so many methods to reduce the static power consumption, to reduce the dynamic power consumption. So that is only possible with you guys. So you know this formula. So capacitance and voltage and frequency are proportional to the power. Okay, there are some powers which power consumption, power wastage or power loss through leakage and power loss through short circuits means uh, yesterday I have shown, right, testing. In the testing, there are so many different things like defects, faults, errors, failures. So if you see the defects, whenever one chip is having a two pins, okay, outside they can see they look like a two pins, but when you go inside, they may short each other. Okay, so that's a defect. So that leads to so much power wastage. Okay, power consumption. Okay, just now we discussed about dynamic. Right. So if you see a SOC as a suppose if SOC has some subsystems, each subsystem if you see as a node, okay, one process node. Thus, that node needs a very low area, right? They required very less area. In that less area, we have to include all our whatever the logic is there, so that whenever the area is reduced, component size is reduced, so area is reduced. Whenever component size is reduced, we try to fit the more components in that area. Okay, so this leads to a kind, more power consumption kind of a thing. Okay, and those uh, need to be thermally limited, right? So suppose I'm using a Google Pixel phone. So what I observed is it consumes battery drains very fast, and it battery charges very fast, and it produces so much heat. Okay, so they are not, as of I know, they didn't do the power gating properly. Means, suppose if some block is not required power, they has to gate that power. Okay, and what is the another challenge? Different power domains in the chip is increasing day by day. Okay, understanding those power domains is the challenging now. Okay, and as I told previously, there is no single metric which can handle all these challenges like battery life, package inductance, reliability, electromigration, static IR drop, decap or transient IR drop. I think most of you know about electromigration. Okay, suppose if you see the step called metallization in the fabrication. So if you see there, they do the metallization as a layers. Okay. When they are moving from one layer to another layer, there is a thin layer which is connect the layer and below layer and the above layer. So as electron moving with a very fast in that thin layer, so that electrons, the material in that wire will mm, will move from one place to another place so that we can see the gaps in the wires. That's called electromagnetic. So material itself start moving because of the speed of the electron in that thin layer. That's electromigration. So that is biggest challenge, and we need so many techniques to control the electromigration. So the power density, so means for a low power, sorry, for a low size area, how to manage the power density and how to manage the various power domains, right? And how to manage the battery life. All these are challenges when we are going with the low power design. Okay. And if you see here, now you can able to understand various multi VDD. Okay. Same MOSFETs, same CMOS, but VDD will be different from one area to another area. If you see here, there are three domains. One is 1 volt, 0.8 volt, another 1.2, and here few more are there, 1.5 volt. Okay, there are various power domains. Okay, and those are multi VDD. Okay, and some people are called as power islands. Okay, and there is a requirement of clock gating. There is multi VTH threshold voltages, different threshold voltages we need to required, and low power intellectual property means to control all these things to manage the power. There is a separate IP is required. Okay, that needs to be work at low power. That is one more challenge. Okay, so like this, so many things are there. We will see few of them one by one. Right. Right. So these are the various techniques to reduce the power. Okay, somehow manageable, which are called clock gating. Means as soon as the clock requirement is done to a particular subsystem, we have to control the clock to that particular block. Why we need to control the clock? Did anybody can answer this? Why we need to control clock this much? So which is extremely consume the dynamic power. Okay, we have to gate it means we have to control it. Why we need to control it? Did anybody? Just give a try.
Synchronization, sir.
Uh, Synchronization will happen through clock, but synchronization is also depends on other signals from a block also, na sir. Especially I'm talking about clock. Anyway, synchronization is a good point. Any other?
Maybe to stop clock propagation, sir.
Uh, Propagation.
Maintain the processing speed.
Processing speed. Sir, nowadays the chips are coming with a single chip is coming with a multiple processing speeds. Within the system, within the SOC itself, we are controlling the speed of the clock and we'll make the things to work in a different speeds. Suppose did you ever observe your
To
phone
avoid
will
to avoid
work to
to
avoid
avoid unwanted flickers.
because those things will be verified at the level of physical verification, sir. Anyway, system will over the period we will see the flickers, but in the initial times of SOC release, in the initial times of chip usage, we nowadays we are not seeing the flickers. I'm saying
For
something.
one more point, sir.
Hmm.
By this clock, the device get the input by on time, sir.
Yes, sir. It's a little the much related. I'll tell you, sir. There are two requirements, sir. For any SOC, there are two requirements. One is I think as you guys all are digital design knowledge, clock never dies. I hope you agree my point.
Yes, sir.
As soon as system starts wake up, as soon as PLL starts working, means as soon as the crystal is oscillator will oscillate, it will produce the particular signal to the PLL. So now PLL will wake up, then system will come into the wake up situation. So once it started wake up, so you never see clock dies. Clock never dies. This is the fundamental rule of a digital design. This is the point number one. Number two, as soon as system comes to wake up, it has to be in the known state. As soon as we remove the reset, system has to be in the known state. These two are the fundamental requirements to any digital design. Even these two are the fundamental for the verification engineer. Verification engineer first he will look for the how clock is coming. Is it continuously be there or it is dying? First thing he will cross verify that. Next thing is as soon as I remove the reset. So as soon as we apply the reset, system is it is called as system is under reset. Means system can't produce any kind of output. Okay, system will reset all the signals. As soon as we remove the reset, it has to be in the known state. See, as soon as if I on my display, whatever the photo I kept, that has to come, right? Different things should not come. Okay, so clock never dies, sir. Once system starts working is because of clock, as sir told. Once it is going on, it won't die, right? But we can control, like we can gate the clock, okay, or we can reduce the frequency of the clock. Other than that, it never dies. Okay, so most of the subsystems when you are using a phone, when suppose I'm using my phone only for making a call or receiving a call, but so many internal things will work. For all those things, clock is required. Okay, so as soon as some other subsystem is not required the clock, so for a time being, for some time, we have to gate the clock there. Okay, as soon as required, we need to switch on the gate. Okay, it doesn't mean that we are stopping the whole clock. Okay, clock will continuously come. Okay, clock gating is the ultimate technique. It introduced very 4 or 5 years back only. So as soon as we are getting the clock, the clock whatever the clock is consuming power, that will reduce somehow. Okay, there are other things also. Uh, see, as we need to understand there are various power domains, right? Like various voltage domains also there, and various threshold voltage is also there, multi VTH, multi VDDs. We try to reduce those multi. Okay, so we need to be have a very less number of VDD, multiple voltage domains or multiple voltage thresholds. Okay, that is what voltage scaling means. As less VDDs, as less voltage domains you have, you no need to scale the voltage from one domain to another domain many times. Okay, and as power domains, we as the power is changing from one domain to another domain, we need to switch the power, right? For that switching, there are some techniques. By using those things, we can reduce the power. Other than all these things, the main thing is activity reduction. Okay, so means the suppose if I'm using my mobile only for calling and mobile or the phone call and phone the call receive, there are so many other blocks which are continuously running. If we try to reduce those blocks running, their activities, if we try to reduce their activity, then it will become a power efficient design. Okay, nowadays, even though if you switch off the phone, if you switch off your phone and check the battery percentage, try to switch off the mobile and see in the early morning what is the battery percentage. Okay, you will see at least some percentage difference. Okay, that is because even though you switch off the entire system, still there is a power consumption. I'll tell you what are those systems which are still running when you are in the switch off condition. Uh, this is power management unit, sir. Nowadays, people are introducing their own way of power managing things. So they are designing their own power management units. So I think this is a very good research topic for a people like you, because it is for a designers, it is a requirement. Okay, for various industries, power management is the requirement. Power management units are very much required. So this is my uh, previously worked thing, but not complete one, but partially I put here. So there is a power management unit state mission. That statement is the way bigger than we have ever seen. Okay, that much bigger state machine. One state machine will trigger 3 more state machines. Each state machine will trigger few more state machines. Like that, it will work. And it is having a one more block called WIC, means wake up interrupt controller. So many interrupts will come when system is waking up. Okay, means processor will put so many interrupts when system is waking. Means like, can I switch on this module? Can I switch on this subsystem? Can I switch on this subsystem? Can I switch on this? Whenever the system is booting up, it will produce so many interrupts. Okay, so that also need to be verified in the verification level. Okay, and there is one more block called always on. Even though where our system is under switch on or under switch off, this block is always on. Okay, there are some peripherals, there are some blocks on your system on a SOC which are always on. Okay, in order to control all these things, as I told yesterday, there are some registers. We need to configure those registers. Means we need to write the values to the register. That register invoke the state machine. That state machine will control the data flow data flow in your logic. Yesterday I told. Okay, for here also this management unit, this power management unit also come up with some registers. If I configure those registers values will invoke the state machine. That state machine will send the signals to the particular blocks, to the subsystem or to the wake up interrupt controller or to the always on block, and their data flow will start. Okay, we will see what are the various states this PME is having. Somehow I didn't write all the states. I wrote only 7 or 8 states. Okay, there are around 25 states. Out of 25 states, around 6 states will invoke each. Out of 25, 6 states will invoke a 6 state missions. That state missions will have around 10 to 15 states. In that 10 to 15, three states around will invoke the some other state missions. Okay. Uh, this is the power management unit. So this is one kind of a power management unit. This is another kind of power management unit. Okay. So this power management unit is working on a 2 modes. It's operating in 2 modes. One is on and sleep. Okay. In the on mode, it reads the input data stream and interleaves them and stores them in the memory before driving them onto the outputs. Okay, under on mode. Whenever it is in sleep mode, it monitors the inputs and maintains the states of its memory, but it doesn't process the inputs. It will look for the memories and other kind of things, but it cannot process the data when it is in the sleep mode. To control this whole chip in the on mode and sleep mode, there is a unit. There is a power management unit. Okay. So this is one kind of power management unit. This is another kind of power management unit. So I'm suggesting all of you to have some work in on a power management unit. It will help us a lot. So now we have seen the power management unit, right? So this SOC will have a different modes of power. Okay. One is normal mode. Okay, another one is low power mode. See, as soon as system starts working, it will work in the normal mode. Okay, as keep on it's going, it will slowly go to the low power mode. Okay, so by invoking all these guys, these are the various states names in the low power mode. Okay, means wait transfer to the finish, enter into a self refresh. So in the olden times in our laptop, we try to right click and we'll try to do the refresh. Nowadays they have a separate circuit which will refresh all the time. Okay, if we can't refresh, there are some kind of memories in the system. They may the data in that memories slowly they'll fade. Okay, so data is on in that memory, slowly it will fade. Okay, so because of that dynamic capacitance, so that we need a requirement of one circuit, which will do the refresh all the time. Okay, and once processor working on different things. Okay, we need to get the processor clock. We need to increase the clock frequency from one particular value, very lesser value to 32 kilohertz. From there, it will go to higher frequency, 24 megahertz. Okay, so sometimes it is a requirement of power up the core. Sometimes we need to reduce the power to the core. Okay. We can come out from the, suppose if I put my system in the sleep mode, okay, or in the hibernate mode, there is no need of refresh requirement, so that you can exit from the self refresh. So I want you to understand these are not one after the other. Okay, first normal status, then wait to transfer to finish, enter into. This is not one after the other. So these are the various states in the low power mode. Okay. Uh, See here, when it is in the normal mode, there are only two configurations. Configure your DDR memory to self refresh, DDR IO retention, and DDR IO power off. I will tell you what is retention. Power domain, power down power domains, and for various power domains we need to power down in the normal mode. After some time, still the system is under uses. Slowly it will come to a state called low power mode. Okay. Mostly SOCs are having these two modes, normal mode and low power mode. But when it needs to come to low power mode, when it needs to go back to the normal mode, it depends on the individual design. Okay, these are the various states, mostly you know this thing. System is in the ideal state and system is in the sleep state, system is in the run state. Okay, those are interdependent each other. So the verification confirms that design is still correct after the optimization. Still, if I'm switching the power states, the operation of the subsystem need to be done as a requirement. Suppose I put my state in the sleep. So subsystem has to work according to this sleep state. Okay. So there are some other internal states to the sleep mode, which are active, flexi, hibernate, shutdown. So the flexi is a thing. Suppose I worked a lot. When I want to sleep, I need some peaceful environment, right? So for that, I need to switch on my AC. So this flexi will work like that. As soon as it observes the system is under so much work stress, or a system is working on so many operations. Slowly, it will on the things like a to cool the systems. So that is called flexi. Okay, we have a fans, right? In some laptops, there is a on the keyboard there are some switches to control that fan speed. If you increase the fan speed, so much heat can be taken away by the fan. So system will come to a cool state. Again, it will work effectively. Okay, so it is just like a human being. So this is always on. Look, these are various statements from the various companies regarding always on block. So if you see here, the critical functions like a power management unit needs to be always on. Whatever the wake up triggers are required, those need to be always on, because as soon as I switch on the power button, first those triggers will wake up, right? Means those are not in the situation like they switched off. Whenever I press the power button, they are switching on. It is not the situation like they're always in the on mode only. As soon as power will go, one signal will go to that block and start triggering those guys. Okay, but those blocks are always on. Okay, there is a thing called RTC, real time clock functionality, even during in the sleep modes. Okay, now these always on blocks will be different when the system is in stop, when the system is under on, right? See, I put one example here. I know, don't keep, right? See, this sounds simply, but designed with the 200 managed power domains has a minimum verification state space to power 200. Okay, so this in order to verify this always on block, we need to be we need to have a uh, separate test cases, or we need to have a separate state spaces to verify this always on block. Okay, so this much is available in the internet regarding always on block. If you ever experienced any project like very bigger project, there you can see this block completely, this always on block. Okay, so now as soon as the system is in the low power, right? So this low power verification, this how this low power is, are we able to optimize this low power or not? See, the chip is requirement of power is very less, right? That is not happening properly or not. We need to see this one. Okay. Low power verification is the systematic process that ensures a chip design adheres to its specified power consumption targets, employing various techniques to minimize energy while maintaining performance standards. Okay, and the importance of this verification. As a consumer demand skyrockets for energy efficient devices, verifying low power consumption becomes a imperative for prolonging battery life and minimizing operational costs, thus enhancing user satisfaction and product value. Okay, so for this, they are introducing a separate method called UPF. Okay, Unified Power Format. Okay, serves as a standardized methodology for defining power intent in integrated circuit design, enabling designers to execute power-aware simulations effectively and efficiently. Okay, if you see here, always on block and power control blocks are very small, but have a far-reaching impact on the controller's activity. Power-aware simulations must be integrated as part of a functional verification of the controller and all entry and exit mechanisms of U3 power state. See, this U3 power state means USB is having a so many power states. Okay, in that one of the state is U3 power state. Okay, so the low power verification is a one particular domain where we need to verify the power management of SOC. Okay, this low power verification is also called as a power aware verification. So if you have a so much interest on this thing, so you can switch to this domain, which is a low power verification. Using UPF, Unified Power Format, we will verify the low power management in the on the chip. Okay, so this flow must cover the following spaces. Okay, water. So incorrect application of voltages or unplanned voltage states, power on reset sequences. Okay, voltage monitoring and handshake logic errors, logic conversion errors, memory corruption and voltage race errors. This memory corruption is nowadays we are facing a problem regarding this memory corruption. So in order to verify all these things, there is a thing called low power verification. We can call it as a power aware verification also. Okay, let's talk about this UPF sometime so that you will get a little knowledge towards this thing so that we can understand how a power is analyzing at the low power level. Okay, these are the various things in that UPF. That UPF, as I told, unified power format. This file is called as a TCL file, .tcl. So after this session, I'll provide one sample UPF file so that you can understand how a UPF will be. Okay. So then here I didn't mention as so specific how to UPF, how to use this UPF to verify the low power situation of the design. So if you have any interest, anybody is having any interest, please just ping me or just mail me. We will discuss. These are the various things which are in the UPF. Okay, different power supply nets will be there. For all those things, we will create a power supply net. As I told previously, various domains will be there, power domains. For that, we need to create some power domains in the UPF, and supply ports will be there. Supply ports means 1.2 volts port, 1.4 volts port, 0.8 volts ports. All those power ports we will create. We will create this. We will create a ports in the UPF in order to verify those things. These are already there in the design. When it comes to low power verification, we need to create all these things in the UPF. Okay, using these things, we will verify all those domains. We will verify all those ports. Okay, so just a minute. Okay, and people are banging. Just a minute, sir. If you have any questions, you can ask me in between. I will be free by 4 p.m. Okay. And we need to create an association between ports and nets. Okay. From the port net will go, right? So we need to create that one and create primary power grounds for each domain. Okay. So primary means those domains need to be those domains need to have two things. One is ground power, one is maximum power. Okay. Those we need to set. And we have to create a power switch, and we there are other components also. All these things we have to write in the UPM. Okay. If we have knowledge, we will write these things. So many people ask for review already. Okay. If you don't have a knowledge to write all these things, physical design engineer, if we ask them, uh, as of coming to our project, we asked our PD engineer to give this UPF. He generated the UPF and he gave it to us. So we just cross verified it once and we applied it on the low power verification. Okay. Yes. Now in the design, suppose one domain is working on 1 volt. This call is torturing me. Okay. So there are two domains. One is 1 volt domain, another one is 0.7 volt domain. Okay. As one signal is going from one domain to another domain, there is a thing called level shifter. All these level shifters are embedded in the design. So we need to verify that level shifter is working properly or not. Okay. So see, as I told you, right, in the see, previously maximum chips are coming with a one kind of a voltage. Now we are having a different voltages, right? So in order to switch from one signal from one domain to another domain, there is a need of level shifter. Designer will embed that level shifter on the in the design. Okay, that level shifter is working properly or not, we need to understand in the when you are doing the power analysis. My God. Okay, sorry for the abduction. See, there I wrote two statements very clearly. Okay. See, in this domain, in this 1 volt domain, logic 1 means 1 volt. Logic 0 means 0 volt. In another domain, logic 1 means 0.7 volts. Logic 0 means 0. Okay. See, don't think like a 1 is always 5 volt. It will vary from domain to domain. Okay. So now this 1 volt, this logic bit 1 in this 1 volt, as it passes through the level shifter, the logic 1 will become a 0.7 in that domain. Still it is logic 1, but the voltage is changed. Okay. Translate signal values from an input voltage swing to a different output voltage swing. Okay. If you see there, A1, a 1 tick B1 driven by 1 volt logic may be too much for a 0.7 volt logic. And likewise, 1 tick B from 0.1 volt logic may not translate into a 1 tick B 1 volt logic. A level shifter changes 0.71 to a 1 volt 1. So you are propagating a valid digital values through the circuit. Okay, these level shifts, as many as you have a different voltage domains, these level shifters will be there all over the chip. Those many, see, this is the, as I told you, right, create a power supply net power domains, right? See, in the UPFL, we have to write like this: create level shifter rule minus name. We have to give our own name to which domains it is working, PD1 and PD3, right? For a PD1, PD3, can anybody guess what is this PD1 and PD3? Those are two power domains. For those two power domains, we wrote the UPF, right? See, create power domain rule minus name PD1. Okay. In that PD1, how many devices are there? All those things we have to write there. Okay. So between domains, we can level shift, or between different voltage domains, we can use this level shifters. Okay. Changes the voltage from one discrete value to another discrete value. Right. So I hope you understand what is what is the value of logic 1 in one domain is different of this logic 1 in the another domain. Okay. Next. Then isolation cells. Okay, so these are extremely important for SOC. Okay, there is no SOC which are coming with the level shifters and isolation cells. Okay, there is no other chip. Isolation cells are typically used to protect the logic that is powered on from the logic that is powered off. For example, I want you to listen bit carefully. Uh, see, suppose this one, you follow my cursor. See, suppose wherever my cursor is there, this particular part of the logic is not at all required when this is working. Okay, so there is a situation, right? Like, so suppose this entire SOC is processing one particular application. Okay, for that particular application, there are so other logics which are not required. Okay, so but we need to understand. See, this block having a connection with this block means one of the output from this block is input to this block. Okay, but when this is working on something, that particular input is not required from this block. Anyway, this block is not in the active mode. Okay, so we need to keep a one isolation cell here so that we can separate this block, and we can, whatever the output which is coming from here going as input to this block, we will pass the value to that signal through isolation cell. Okay. So this isolation cell will make other logic completely out of another logic. Okay. If it is not in the working mode, suppose this is not in active mode, this isolation will separate those two logic blocks. Okay. Separate one each other, and it will make whatever the block which is need to be work, isolation cell will make that block work independently. Okay. So whatever the required signals are there, isolation cell will produce. Okay. So because of this isolation cell, we can cut off the power to the blocks which are not in the working. Okay. So see, the statement is isolation cells are typically used to protect logic that powered on from the logic that is powered off. That's what I'm telling. Whatever the signal which is coming out of this block to the another block, suppose signal is coming, but this block is not in the active mode. Okay, this block power is already switched off. Whatever the signal which is going from here to here, anyway the block is not in on, right? So it won't provide the value. So isolation cell will put the default value to that signal, and that signal will go to this block. Okay, this orange color block. Okay, when it comes to this isolation cell, we have to verify all these things. That is there any isolation cell is missing? Is there any iso cells are unnecessarily are there? Okay, repetitively are there? Okay, whether that locate in the off block or at the on block. Okay, always on isolation cells are located in the on block or not. Isolation cell data pin is driven by always on constant value or not. Isolation cell output is floating, means isolation cell is unconnected or connected. Okay, missing is different, unconnected is different, right? So floating means it's not connected. Isolation control signal is wrong polarity, means whatever the signal you're driving defaultly, that is going with the proper value or not. Like this, there are 11 scenarios where we need to verify the isolation cell. Okay, if this isolation cell working properly, so that we can isolate the one particular block. Okay, and we can power off that block. Whatever the blocks are isolating from these isolation cells, power to all those blocks will be cut down. Okay, that is the beauty of isolation cell. You can also use it to prevent leakage current from a live logic, from improperly powering unpowered logics. Okay, so it will passes logic values during normal mode operation and clamps its output to some specified logic when the control signal is asserted. Okay, asserted means uh, it is high. Okay. So I want you to understand what is a level shifting, what is isolation cell. There is one more thing called retention cell. Okay. So this name itself is telling that retaining, right? Retaining means keeping. Okay. A sequential element that can retain its value despite being powered off. Okay. One block is powered off. Using isolation cell, we powered off, right? If that block need to be whenever it comes to active, it needs to work from where it stops, right? So in order to hold that last value, there is a block called retention registers. Okay, they will store the values. They'll store the last functional values. Okay, whenever that block again come back to active mode, this retention register will produce the data. Okay, this is the place where you stopped working. Now you can continue by taking this value. Okay, extends the functionality of sequential element with the ability to retain its memory value during the power down state. Okay, by isolation cell, we isolated one block. Means we are cutting very soon. We are cutting down the power. So, but that block need to be active after some other time, so that it has to retain its last functional value. That will possible by retention cells. There are two styles. One is master slave alive style, another one is balloon style. if you have interested to work on these things, just go by those two styles. Okay, those two styles come up with two different state missions. Okay, and we will write a retention cell in the UPF file like this. Okay, a simple example I gave there. Useful to recover the last known state of the design when power was removed. Reduce the amount of time needed. Reset a design to a specific state to continue operation. Okay, I hope you got the point. See, what is the first thing? Level shifting. So when we need to shift the level from voltage value from one domain to another domain, level shifter is required. Next is isolation cell. If you want to cut down a power to a particular block, you have to isolate first. Whatever the block is producing the outputs, those has to be default values through isolation cell to the another block. Okay, next. So after isolation, you have to retain the last functional value of that block to continue whenever it is in the active situation. These are the various power domains. Okay, so this PD1 is one domain. This PD1 is having a three more domains, which are PD2, PD3, PD4. Okay, don't see like a different domains. In the PD1 itself, in the power down one itself, there are three domains. One is PD2, PD3, PD4. Means instant 1, 2 is in one domain. Instance 3 is in one domain. Instance 4 is one domain. All these things are in the one domain. Right? Now, this mux and this P instance. Okay. This P instance is nothing but a power management unit. This power management unit and this mux is working in a which domain? These two are working in the PD1 domain. Okay. So inside this PD1, this instance 1 and 2 is having PD2. So we will write a UPF for the domain like this. So I told you, right, when we are discussing level shifter PD2 and PD3. So for this power domain, we named it as a PD1. Okay. In that, how many domains are there? Three domains are there. One is PD2. See, there is a create power domain minus name PD2. Inside this PD1, there are three domains: PD2, PD3, PD4. Okay, a collection of instances that are treated as a group for power management purposes. Okay, the instance of a power domain typically, but do not always share a primary supply set. See, the supply sets means you remember, right? These power supply nets, power supply ports. Okay, these power supply ports and nets are different from domain to domain. Okay, so the power is switching from one domain to another domain. It will switch through the power ports. Okay, it will switch through the power supply nets. Okay, those are before you are creating this domain in the UPF, you have to create the how many supply nets are required, how many supply ports are required in the UPF. You have to write all those things. Okay. See, as I told you previously, there is a state machine in the power management unit. Okay, it is having these four states. One is main state machine, another one is MRAM state machine, another one is core state machine, another one is RI subsystem state machine. RI means reset and initialization subsystem state machine. Okay, those are internal states. So this this main state mission is having a those six states. Okay, each state is having a few more substates. Okay, ultra deep sleep. Okay, subsystem off, subsystem deep sleep, subsystem sleep, and active. Okay, this main state mission is nothing but that PMU state mission. Okay, this core state mission is nothing but whatever the processor you're having. Suppose you have an ARM processor, ARM state mission. This is okay. It is having only two things. One is clock gating, another one is on. Okay, this reset and initialization subsystem is having these things. See, as soon as system comes to the wake up state, it has all those things, right? It has to boot up. Okay, it has to it first initially it will come to ideal state, then it is low power, then it is ultra low power. If you want to move it into a high power requirement, like that. Okay, this MRAM is nothing but our rams. Okay, first it is in the on, then it is power up, then it is power down, then it is continuously on, right? These are the various states in that state machine. Okay, this is multi-power domain methodology. So I hope if you go through these things, then you will easily understand what exactly is happening in the power management. Okay, just to go through once this briefly. First, data flow diagram. So this all thing is about power requirement only, not the design. Okay, not the logic design for the various applications. Okay, all those things are done. Once all those comes to a conclusion, then they'll work on the power management to that particular architecture. Okay, understanding power partitioning requirement, how to partition the power, then decide on voltage islands or power domains. Okay, module grouping into each power partition, cross check against data flow diagram. Okay, as our requirement, power is partitioned or not, power domains are created or not. Okay, so whatever the groups we divided, are they causing any data flow issue? Okay, suppose we designed our boss, door close the boss. Okay, suppose we designed our logic, right? We have to keep some of the logics in the one domain, some of the logic blocks in one domain. So because of these domains, their data flow is mismatching. Then again, you go back to the power partition. In further, you have to go for the always on and power control signals. Then review power management states and generate a list of AI signals, level shifter requirement, isolation cell requirement, retention strategy we need to require. Okay, that retention strategy is also one of the research domain. Okay. Okay, start building the power flow diagram, then power architect. Then see this side is all requirement review, and now they are placing. Okay, so then is a flow as per power states. See, in the power management unit, there is a power state mission, right? So that according to that states, it is working or not. If not, you have to go back to the flow. Okay, then create a UPF. Okay, I told you, right? If we want, we can write our UPF. Otherwise, PD guy will give you the UPF. Okay, and they'll give you the, if they place level shifter, there is a tool which will generate the UPF file for the level shifter automatically. Okay, we will extract all those things, and each voltage island shall be a separate ring around the block. Place the level shifter isolation buffers for a signals as per UPF. Place ion buffers as per UPF. Place power switch and add rings and strips. Okay, all these things are in the time of placement and routing. Right before this, after the exporting the UPF, so we will verify those level shifters, isolation cells, retention strategies are working properly or not. Once that verification engineer approved those things are verifying properly, working properly, then they'll do the chip fabrication, placement and routing in the physical design. Then they'll go for the what is that packaging, right? So this is actual following up. Okay. Next, see, this is same thing which we will try to make you understand in the different direction. Okay, first we will write our RTL, then we will write UPF. Okay, by using those two things, we will create one soft IP. Whatever the IP you are creating, that is hardcore IP. Once it is embedded with UPF, then it is soft IP. Then we will configure that UPF. Okay, then we'll release that. See, this IP configuration, once it is done, verification engineer will verify that UPF is working properly or not. Then they'll go for the synthesis and placement routing. Okay, then they'll generate the netlist. After the netlist, it will go for the fabrication. Okay, so this is the from RTL to end of the line. Okay, implementation of low power thing. Okay, in the initial days, these level shifters, isolation cells, retention cells, different power domains, different voltage domains, all are not there. Okay. So these are the different combinations. Suppose if there are multiple voltage domains, level shifters are required. Isolation cells are not required. Power switches are not required. Retention resistors are not required. Always on logic is not required. Okay, multi supply with shutdown, no retention. Okay, then isolation cells and power switches only required. Multi voltage with shutdown, all these three things are required. To make it shut down or switch on, power switches are required. Okay, multi voltage with shutdown and state retention, this is the finest thing, right? Last one is required all things. Okay, these are the various tools for the power aware simulations, means low power verification, which is Synopsys VCS, Mentor Graphics Quest, and Cadence Incisive. Okay, so I mentioned this thing previously, right? We need to verify these things. Okay, this is the power aware test bench. As I explained about test bench yesterday, same test bench we will have here. Okay, so and we will verify that power management unit, and using UPF we will verify retention cells and what is that isolation cells, all those things. Okay, so this is the this is how we will verification engineer analyze the power in VLSI. And there are some places where we can estimate the power by using a tool. Okay, suppose if you see the Zailings tool, if you see the Zailings tool, it is having a power estimation tool. Okay, after your logic design, how much power it will require, like that it will give you some power details. Okay, those are not much enough to understand deep, and those are not enough to understand the deep when system is working with a so many operations at a time, then that power analysis is not enough to understand. Okay, so this much is about power analysis. Now if you have any questions, you can ask me.
These
You can
participants
ask.
can interact with
Yeah.
users person, please.
Yes. Yes. You can ask any question. Don't worry. Don't think too much also. Did you understand whatever I explained so far?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yeah. Thank you, sir.
Anil, sir.
Yes, sir.
Sir,
Shall I
sir.
go? Madam is there.
Sir.
Shangari madam is there.
Prasad, sir. Prasad, sir. Just a minute. Sir, actually, this is Anil Kumar, sir, from GMRT.
Yes, sir.
Actually, I am from antennas background, antennas and micro background.
Yes, sir.
So recently we referred few papers, few publications regarding antenna on chip related to the SOC technology.
Yes, sir.
So we usually design microstrip patch antennas on FR4 and other kind of substrates. But
Okay.
recently chip kind of antennas are evolving. For that, they are using SOC technology.
Mm. Okay,
So
sir.
they are making on the silicon with some nanometer thickness levels.
Okay.
So is there any possibility of doing work or integrating VLSI and antennas, micro RFICs like that?
Okay. Is there any ways of
Yes, sir.
integrating
Yes, sir.
this? Okay.
Yes, sir. Yes, sir. Have you
So
ever come across the RF related things in your designs and radio frequency and micro frequency related things? Previously, in the some slides, you mentioned the clock frequency is about 10 gigahertz, 30 gigahertz, like that.
Ah,
Uh,
yes, sir.
uh, yes, sir.
No,
Such high frequency circuits required.
okay.
Yes, sir.
I never come across to these RFID, these kind of this antenna and these things. But
RFIC, sir. RFIC, radio frequency integrated
that's
circuits.
yes, sir. Yes, I never come across all those things. But and so far we never verified a chip which is coming up with a these antenna kind of things, sir. See, these antennas and all will come up uh, at the fabrication. See, if you talk about only chip, we will verify only RTL level, sir. Means register level transfer. Oh, okay.
Okay, sir.
Register transfer level only we will verify. By the time we don't see any kind of these physical things, right? So we will verify how antenna will produce a output like this. Antenna will produce a data of stream like this. That stream we will verify, but I never come across all these kind of things, sir. So
Okay, sir. Okay, sir. Sir, there is
yeah,
one question in your chat box.
yeah.
Can I read it? What is the
Different.
difference in terms of percentage between pre-layout and post-layout while considering the hardware parameters?
Okay.
I repeat, sir. What
Yeah,
is the
I'm
difference?
seeing the questions.
Yeah,
Yes,
yeah,
sir.
yeah.
What is it different in terms of percentage between pre-layout and post-layout while considering the hardware parameters? Uh, as far as I concern, um, see, they'll manufacture the chip in terms of pins, sir. See, that suppose if you take a 80, let's talk about we are designing the 8086 microchip, okay, microprocessor. So it is coming up with the 40 pins, okay. So as whatever they told, right? We are having a only 40 port level signals, so you need to give the data through those 40 out of those some of the input, let's say 25 are input. You need to produce the data and give it to the 25 ports. So, and that will produce some output. You have to take the remaining 15 pins outputs and verify it is producing properly or not. You will see the physical pins after the post layout. Okay. So as for our concern, how many input and output ports are there for a module? Only those things we will cross verify, sir. So we don't go by the post layout things. Okay. And so as far as I concern, for us the hardware parameters are the only those module level port signals. Okay, we will think that those are only hardware parameters. Okay.
Okay, sir. Okay, sir.
Yes, thank you. Any other question?
Yes, participants, please, you can interact with the speaker.
Anybody can ask questions about this power related things.
Sir, your sessions are very informative, sir.
Yes,
The points particularly addressed by you regarding the power related things can
yes, sir.
be, it is very much useful when we integrate into the regular academic teaching. While
Yes,
dealing the VLS and other microprocessor related subjects and IoT and all.
yes,
Thank
sir.
you, sir.
Yeah.
Shivshankar, ma'am.
Sir, a small doubt, sir.
Sir,
Yes,
please
sir.
proceed, sir.
Welcome.
Sir, actually, dynamic power, static power is there.
Yes, sir.
And apart from that, short circuit power, sir.
Yes, sir.
So suppose you want to calculate the total power of the circuit, which are the power we have to include, sir?
Uh, Actually, tool will estimate all those things, sir. So, as see the power estimation tools are developed like it will go by the every kind of a power consumption things, and it will calculate all those things, sir. Not so specific. If you want so specific, tool will allow us to give that particular inputs. I want to know how much exactly power is consumed by the short circuit. So that tool will provide only that particular information. Otherwise, if you are not in a position of giving any inputs to the tool and you want a power estimation, it will consider all those things. It will go to every port, it will go to every net, it will go to every logic block, and it will try to check every logic how much circuit it is taking, and it will estimate the power and it will give you, sir. All those things it will give you.
Which tool is
Uh,
utilized? Which tool is utilized for calculating the power, sir?
yeah, we have a one particular add-on in the Xilinx, sir. But when it comes to industry, there is nothing like a power estimation tools, sir. There is,
The,
see, they may be specific to the industry. They may be specific to that particular company. They develop their own tool and they will estimate the power. But as far as I know, to the whole VLSI industry, there is no particular tool like estimating the power. But when it comes to your RTL design, Xilinx will provide the power estimation, sir. It will give you the good power estimation values.
actually, I used Silex
Yes, sir.
14.2,
Yes, sir.
but in that only we can see the synthesis.
Yes,
There
sir.
is no power estimations.
Okay, it will be there, sir. Actually, when I was in the college, I worked on it. Okay. You take my mail ID or contact number, sir.
I
You
got it.
just
I got it from yesterday.
yes, sir. I got the voice.
Okay,
I'll tell you, sir, how to do
because
that.
I am also working under low power VLSI.
Yes, sir.
So
Yes,
I
sir.
have so many doubt. So that only you just said to us now, okay, is there any issues related to power you can convey? So that only I asked.
There is one simple tool which is Kentis from NXP, sir. You can try that one. Kentis is there.
Can this mean
Kinetis, Kinetis. There is one tool is there, sir, from NXP.
yesterday also you said okay, Mender graphics. Okay, that is also
Questa
I tried.
sensor.
This is open source. That is also tried to download, and also I
Yes,
plan to work it over there.
yes, sir.
Is there any issues? I will contact you, sir.
Sure,
Thank
sir.
you for your
Always
nice.
welcome.
Thank you for your nice presentation. Yesterday
Yes.
and today you spend with your valuable time with us. So we also got many things from you. Okay, that is
You
also
you
very.
want if you want any UPF file, I'll give you, sir. Later, if you ask me, I'll give you those isolation cells and all those things as I explained. I'll
I
give you
have so
that UPF file
I
also.
have many doubts, sir, because I
Yes,
am
sir.
writing one paper relevant to low power.
Yes,
So
sir.
in that also some results are not get properly.
Yes,
So
sir.
based on that also I will discuss with you, sir. If it any
Okay.
provision, you just give the guidelines to me.
Okay, sir. Sure, sir. Okay.
Okay, thank
Anita
you, sir.
madam
Thank you.
asked one doubt. Can we use a cadence for a power analysis? Madam, for power analysis, there may be a add-on in the cadence. I'll check the tool in my office in my company, and I'll tell you if there any add-on is there in the cadence. But cadence is having a tools to verify the low power, madam. Low power verification, there is a cadence tool. Using cadence tool only, we can verify the low power. But there is not sure, there is no power estimation or there is no power analyzing tool directly add on. Okay, you just ping me through WhatsApp or through mail. I will tell you the add on if it is there in the cadence. Synopsis also our people are working. I will check there and let you know, madam. Yeah, thank you. Meanwhile, you can try Kinetis, Kinetis from Kinetis from NXP. Let for check once if it is open source, you can download it. If you have any other question, you can ask.
So I think there is no more questions, sir.
Yes, madam.
Prasad, sir.
Ma'am,
Now you can go ahead, sir.
thank you for giving me the opportunity, madam. Good evening, sir. Good evening to each and everyone. This is Dr. N. Prasad, Senior Assistant Professor in EC Department, GMRIT.
Yes.
It's my privilege to deliver the vote of thanks for this 6 days ATAL FDP and VLSI design innovations for defense applications. First and foremost, I would like to extend my heartfelt gratitude to Chief Guest Mr. Nagasubramanian sir for gracing this event with his delivering an inspiring and interesting topic on power analysis in VLSI. Really, your words are have been truly enlightening and have set the perfect tone, sir, for today's gathering. And sir, I have observed some topics, sir. Those are very interesting to me, especially power analysis in VLSI, static power consumption, dynamic power consumption, techniques to reduce power like clock gating, voltage scaling, switching power technique. What is sleep time? What is sleep mode and on mode in power management unit? What is UPF? All those things are very, very much useful for in the academic point of view. On behalf of the EC department, GMRIT, thank you, sir. Thank you for accepting our invitation and sharing your knowledge. Thank you, sir. Thank you very much.
Thank you, sir. Thank you.
Thank you, sir. Thank you so much for your wonderful session and spending your time.
Yes, ma'am. Thank you.
Thank you, sir. Thank you.
Yeah. Okay, thank you.
So our next session guest speaker has come. So the next session will be handled by Dr. Anand Nair, sir. So Anand Nair, sir, we welcome you, sir, for the ATAL
Yes,
FDP.
good evening, ma'am. Thank you for
Good evening,
welcoming.
sir. Yes, yes. So now I request Dr. Sharmati ma'am to introduce the guest to all the participants.
Thank you, ma'am. Good evening, sir. It is my pleasure to introduce today's resource person, Dr. Anand Nair, sir, who received a PhD from Deshbhagat University in 2017 in the areas of wireless sensor networks, swarm intelligence, and network simulation. He is currently working in School of Computer Science, Duet Tan University, Da Nang, Vietnam, as Professor, Scientist, Vice Chairman of Research, and Director of IoT and Intelligent Systems Lab. And Sir is a certified professional with 125 plus professional certifications from Cisco, Microsoft, Amazon, EC Council, Oracle, Google, BeingCert, Exyn, GAQAM, CyberOhm, and many more. And Sir is a member of more than 60 plus associations as senior and life member like IEEE senior member and ACM senior member. And Sir has authored or co-authored, edited 60 plus books of computer science, and as he is associated with more than 600 plus international conferences as program, committee, chair, advisory board or review board members. And Sir has awarded 50 awards for teaching and research, Young Scientist, Best Senior Scientist, Asia Top 50 Academicians and Researchers, Young Research Award, Outstanding Research Award, Excellence in Teaching, Best Senior Citizen Award, DTU Best Professor and Researcher Award of 2019, 21 to 21, 22, 22 to 23. Distinguished Scientist Award by National University of Singapore, Obada Prize 2023, Lifetime Achievement Award 2023, Asian Admirable Achievers 2024, Distinguished Academic Leader 2024, and many more. And Sir has listed in top 2% scientists as per Stanford University consecutively for 5 years from 2019 to 2023. Add in text, Sir has ranked as number 1 in Dutan University, ranked number 1 computer science in Vietnam and listed on research.com as top scientist of computer science in Vietnam national ranking. He got 2 and D index of 42 and with a world ranking of 6968. And Sir is acting as Associate Editor for Computer Communications, International Journal of Sensor Networks, Computers Materials and Continua, Tech Science Press, ISAC, and Cognate Engineering, Human Centric Computing and Information Sciences, Piaget Computer Science, IET Quantum Communications, and many more journals. And Sir is acting as a managing editor of IGI Global Journal, USA titled International Journal of Knowledge and System Sciences, and editor-in-chief of IGI Global, USA Journal titled International Journal of Smart Vehicles and Smart Transportations. And Sir has reviewed more than 5,100 plus articles for diverse Web of Science and Scopus indexed journals. And Sir is currently researching in the area of wireless sensor networks, Internet of Things, swarm intelligence, cloud computing, artificial intelligence, drones, blockchain, cybersecurity, healthcare, informatics, big data, and wireless communication. Thank you, sir. We are very privileged to have you here. Please continue the session.
Thank you so much, ma'am, for the elaborative introduction, and I hope you can hear me properly.
Yes, sir.
Yes, sir.
Yeah, thank you so much. Good evening, ladies and gentlemen. I'm Dr. Anand Nair, and I'm working as professor, scientist, vice chairman research, and director of IoT and Intelligent Systems Lab at the School of Computer Science, Dutan University, Da Nang, Vietnam. First of all, it's a real honor for me to be acting as resource person for this 6-day ATAL FDP program for VLSI applications for defense applications. And of course, ladies and gentlemen, this FDP program is going to lay a strong foundation for all of you to conduct advanced research in VLSI technology. And of course, you can understand power systems. And of course, you can integrate the modern and upcoming technologies, especially when we talk of artificial intelligence, that how we can integrate with real-time VLSI applications. So I also thank the coordinators for inviting me. So today, everybody, I will be discussing very important topic. In fact, the topic which is very close to my heart. And of course, this topic is not only being my close contribution, but of course, I'm working and giving lots of things to the society. So I will be transferring you lots of knowledge today in the next 1.5 hours. So please sit back, relax and enjoy the lecture. And of course, take your pen and paper and write down your notes and write down your problems. If there is anything you want me to discuss at the end of the lecture, no worries at all. I will be discussing all the queries and I will be giving you all the answers. And I will try to discuss as many research problems in this part of this lecture. So I will be discussing today, everybody, with regard to Internet of Medical Things and artificial intelligence oriented medical things, that is called IOMT and AI IOMT. Now, of course, everybody, if you talk of IoT, at one time it was just called that connecting the sensors and other devices used on the internet so that we can access them anywhere and everywhere. But now if you talk of IoT, it is becoming diverse, which means that it is not only linked the foundation for healthcare, but also with the power of drones, Internet of Industrial Things. And of course, we can talk of many future things that is known as customized Internet of Things that will be also integrating artificial intelligence and of course, the future of quantum computing. So ladies and gentlemen, today when we talk of healthcare, it is booming. It is integrating technology not only with artificial intelligence and LLM models, but of course, if you talk of IoT, if you talk of sensors, the face of artificial intelligence with cloud computing and big data, and of course, quantum computing, healthcare technology is changing. So this is the foundation for today's lecture, that I will be motivating you to conduct the research in this area. What exactly is this area and what we are doing, and of course all the technical perspectives that is related to that. So presentation is very highly dynamic and of course you will enjoy the lecture. So let's start the lecture. So the agenda is in front of you. I will be discussing first of all about my contributions, research of my lab towards IUMT and intelligent systems technology. Then I will be telling you in depth towards what exactly is IoT as of 2024 and what we can expect in next 25 days when we enter 2025 and what we can expect the face of IoT and of course IUMT from 2025 onwards. Then I will be discussing the detail towards IUMT and then I will be focusing towards more on how artificial intelligence and the focus of robotics and all those connected technologies of AI, and of course, that is called automation, will be integrating towards Internet of Medical Things. Then I will be discussing something about the trends that you can take as a foundation stone, that what you can perform research. And of course, this FDP is towards VLSI, but we need more VLSI people to come and integrate with healthcare technology. And then I will be winding up my lecture with research discussions followed by your questions. So first of all, let me introduce about me and first of all about my lab, and then I will proceed with what we are doing in terms of our contributions, and I will tell you about my projects, and of course then we move towards the lecture. So everybody, you can see my photograph of Google I/O event, and this lecture has got the best lecture award in Internet of Everything. So right hand side, you can see the photograph of LoRaWAN communication, which we have already designed. We already got the US patent. And right now we have the record of communicating with the sensors, which is known as transmitting the information about 3,194 kilometers. And this will be soon integrated with many agriculture fields and industrial fields. And of course, we are in talks with one of the cities in Vietnam to integrate the entire communication network with my LoRaWAN communication. And considering my technology research and contributions towards teaching and of course advancements in computer science and technology, I'm always be the best professor. In fact, I can say I'm the highly decorated foreigner from India in Vietnam. So here is my robot that is already integrated on the airport. And if you are coming to Da Nang City, you can even interact with this robot just recently we have integrated large language models and of course the chat GPT based model in this robot. And if you come to Da Nang City, you can interact with this robot. You can even discuss this robot about your tourism planning. You can even book your flight tickets, book your taxi, book your hotel. And in fact, you can even discuss many things connected to Vietnam government and Vietnam tourism with this robot. And very soon we are in talks that we should replace the receptionist and the paperwork with the hospitals and of course with the coffee shops and of course with the hotel receptions. And very soon by the year end of 2025, you will see that most of the Da Nang City administrations will be connected to these robots. And this is my smart owl that is always connected to Google Alexa and of course HomePod. And it is actually taking all the data that is happening in your current smart home, and it is giving you predictions that in terms that if there is any moisture level high, so what you should perform. If there is any room where have the electricity, it will give you recommendations. And I am having a state of the art drones lab, and you can see that this drones lab is actually giving lots of things in terms of RC planes, autonomous vehicles, and very soon we will be also working on FPV drones, which I'm going to discuss in matter of few seconds. So as the introduction is already done, you can see that I am having my more than 125 plus patents, 10 copyrights, and almost 100 books are published under my name. And I'm the most decorated scientist in Asia. So these are some of the books that you can see, and all the books are right now Scopus indexed, and I'm contributing a lot in terms of IUMT, artificial intelligence, drones. In fact, even today only, just today, you can just go to Wiley and just search unmanned aerial vehicles. Just in the morning, this book has been released. And these are some of the targeting books that we are targeting with IUMT, that is Swarm Intelligence and Evolutionary Algorithms in Healthcare and Drug Development and Emerging Technologies for Battling COVID-19. So these are some of the books that we have already targeted with regard to healthcare. So you can see that we have the top material that is being published under my name. And if anybody wants to download these books, you can go to libgen.is, or in force, you can go to my email, which I will be providing you at the end of my lecture. You can email me and I will give you the copy of these books, no problems at all. So let me show you about my lab and about the office systems that we are using. So here you can see the photograph of my office, and we are using the top systems using Intel, AMD and NVIDIA technology. And we have already integrated the state of the art Mac Pro, which is having 48 gigabytes of RAM. And this is my robotics lab, and we are working on micro robotics that are especially designed for military surveillance, defense applications, and of course, we are working a lot in terms of underground robotics. We are also working a lot in terms of swarm intelligence robotics. We have published lots of paper, and of course, this robotics lab, we believe this is one of the state of the art lab that we have. In fact, we have got one of the most state-of-the-art robot just about 10 days before, and we are using the ladder technology for making it autonomous. So this is one of the best projects that we are working. We have the state-of-the-art 3D printing lab, we have the state-of-the-art robotics lab and drones lab, which I will be showing you right now. So this is my drones lab, and in this drones lab we are working mostly in order to customize the drones in terms of autonomous capability, FPV drone, RC plane, which I'm going to show you. And you can see these are some of the prototypes that are already being ready. In fact, this is the fully customized drone and RC plane that is already ready, and we are doing in real-time applications. And these are some of the controllers that we are using in terms of drones research. So you can see that we have the state-of-the-art controllers that are actually very expensive, and we are also having the state-of-the-art flight simulation lab, which we are setting up for February 2025, in which the students can even learn how to practically fly an aircraft. So these you can see in front of you, that is CX-20 and FlySky, the state-of-the-art controllers that you can see. So this is the first working prototype of RV plane that is called the DTU RV1. And you can see that this plane has even got lots of recognitions. And now we are applying for 7 US patents by 2025 because of its integration, assembly, VLSI technology. And of course, we are working very fast in order to make it fully autonomous. Now, in terms of IoT Intelligence Systems Lab, we are working a lot in terms to make this robotic arm for doctor assistants. And till date, we have the efficiency of 88.67% and accuracy of 77%. And you can see that, yes, efficiency and accuracy is not that high, but still at the level of the ground-based research that we are conducting, it is super good. And we are using NVIDIA Jetson nanotechnology. And very soon, this efficiency and accuracy will be touching about like 90% by April or maybe May 2025. And this is what we can say the top contributions of Internet of Medical Things and Artificial Intelligence things. You can see the BIOS and Health 1.0. After that, we have also designed the D2 ventilator. And this is the world's first Internet of Medical Things with hyperchain blockchain ledger technology with advanced IUMT, which is having high accuracy of 100%. We already have 2 transaction papers in this area. And this is what you can say. We have not stopped till DTU Vent 1.0. We have invented DTU Vent 2.0, the indigenous ventilator when there was COVID-19 situation. And now, ladies and gentlemen, this is the most advanced DTU Vent that you can see. It's a ventilator version 3.0 with advanced pump volume, reduction of frequency of noise, humidity, and stabilizes the gas temperature. So that's the reason my university and me, we are working closely to make intelligent systems. And of course, I will be showing you lots of softwares that you will see, and it will blow your mind. So this is all what we are designing in order to go for real-time contributions for society. And this you can see, everybody, this is the work in progress in terms of the IoT Intelligence Systems Lab. One is the wheelchair. Second is that if you are a patient and you want to conduct some introduction, rather than to have that is called your paperwork, you can just talk to this machine and the machine will conduct all the information and give it to the doctor, give you the receipt. So there will be a paperless hospital. And this is also called the fully balancing robot that can even carry up to like 75 kg of medicines from one part of the hospital to another part of the hospital. So now I would like to introduce some of you about the projects that we are doing for Internet of Medical Things, and of course some of the projects that we have already conducted for real-time implementation for doctors and medical technology. Now, ladies and gentlemen, what if I tell you that we also have our own simulation softwares for our medical students? This is called Anatomy Now, which is providing detailed simulation of system. It is having high integration with VR and AR. We are providing self-study and self-study charisma practice to learn anatomy, and it is multi-platform. So you can see, you can simulate all types of skeletal, nerve, glands and limb, mechanical systems, excretory system and reproductive systems. And you can see the demonstration. So this is the real-time demonstration that you can see in terms of AR and VR. And this is the live demonstration of the patient arm, the legs, and of course, all other parts of the body systems. So it is having the accuracy touching up to 97%. And I will also show you the simulation of the heart. And this is the most detailed simulation that our students are learning the medical technology to the next level. So this is my team that is working with the advanced AR and VR technology. We are using HoloLens 2. We are using Apple Vision Pro. We are also using the Oculus technology from Facebook. So everything is working in the hands, and we are trying our level best to take it to the next level and upgrade it to the best of our capabilities. So these are some of the glimpses that you can see. And in fact, you will be seeing now the demonstration that how it looks like on desktop PC, how it looks like on iPad, and of course with your particular VR and AR cards. And you can see it is on smartphone and tablet. You just need an iPad or of course your Android tablet, and you can simulate everything anywhere. So you can see it is one of the detailed simulation with complete, you can say 360 degree level of freedom. And now, ladies and gentlemen, which I am going to present you, it is going to blow your mind. This actually project has taken us 3 years to develop, and you will see it is on the AR and VR card. Now, this is called the advanced technology that we have designed in-house. You just need a card, just place that card and put it on your phone, and it will give you the entire representation of the human body. Now, imagine if I'm a doctor and I'm giving this medical lecture, trust me, the class is becoming the more advanced class to understand the realistic concepts of the human body. That's what we do in terms of intelligent system design. So this is on HoloLens AR. But we have, soon the video will be integrated using Apple Vision Pro, because we just received Apple Vision Pro 1 month back, and we are working our level best in order to perform that type of simulation. So whatever the part of the body you want to understand, you just drag it there, and it will perform the detailed simulation. So I'm having the state of the art lab in our university, and this is with Oculus Rift VR, that is from Meta. So this has taken us 2 years to build up this project, and right now more than 25 universities in Vietnam and 6 universities in Thailand and 5 universities in Taiwan and 2 universities in Hong Kong. They are well integrated, and we are getting lots of requests from various foreign universities to have this integration for their medical students. So you can see this is about like 100 inches VR screen, and this is where we are doing our projects. So as compared to the other market competition, our Anatomy Now is one of the best multi-platform app, multi-device app, complex simulation, and of course it is having the AR support. So now everybody, we don't want to stop it here. We are also designing our own central CPR training system, and right now more than 27 hospitals in Vietnam, they are using our technology to even give the new nurses. And of course, we want to integrate this technology, that how we can give the CPR to the real-time people, and we can make our students more competent. And you can see it is, as compared to traditional CPR, our eCPR system is a 3D modeling system. It can help the people to practice, and of course it is trained on both CPR and CPR based CAB procedures. So this is having the operation. So we have the mannequin, we have a sensor, and we are handling all the processes using deep learning. To be specific, it is using, that is the CNN procedures, and simulation is based on 3D virtual reality, and you can see the results in terms of improvement of skills and players. So let me give you the demonstration. Here you can see the demonstration. So this entire machine is designed by me and my students, and of course you can see that how the person is going to learn about the CPR system, how to go to the CPR, and the computer is going to give the marks to him. So it all depends that what exactly the marks that you will be getting. So you can see that the machine has given the 100% score, that the CPR that is given by the lady student of mine, it is actually giving the best CPR in this class. So now everybody, now I would like to present you the most state-of-the-art technology, that is the dental practice and simulation. Now imagine everybody, understand, before I give you the demonstration of this simulation, in fact it is called a stage 2 based digital twin. Now imagine I'm a person who is driving the motorbike and I'm good, but accidentally, but due to unfortunate thing, I met with an accident and I break my front teeth. Now remember everybody, I'm going to claim a very big thing. No dentist in the whole world, no dentist again in the whole world can perform maxillofacial surgery in an accurate manner. No dentist, no matter that person is having 30 years experience or 40 years experience, no dentist is there. But what if I tell you that if a patient is going to that dentist nursing home, rather than to first of all start the maxillofacial surgery, the patient can be given that is called your antidote detection for, like you can say, for painkiller. And after that, we can make a 3D simulation model of the teeth, and the doctor will be able to understand what exactly is the complicated situation and how to perform the surgery. So rather than the doctor should perform the surgery on me, the doctor will be performing some surgery on the computer, and after that we can know that what exactly will be the surgery will be performed. And same type of simulation practice we are also working on the next simulator that is coming in July 2025, that will be based on gynecology. That is going to be the absolutely breakthrough in the medical world. So you can see it's a 3D simulation, and I just give you the demonstration right now. So you can see what the teeth you are right now that is getting is actual 3D model of a patient. So if there is any root canal problem, if there is any filling problem, the cavity problem, the maxillofacial surgery, everything can be tested and reality based. Trust me, the simulation is having the accuracy of 99.94%, which is absolutely, you can say, the state of the modern art technology. In fact, you can even see what exactly will be the complete structure of the teeth and what kind of surgery you need to perform. So in terms of the BDS and MDS based sessions of our classes, we have made this state of the art simulation. And of course, right now, almost every dentist in Da Nang City is using our model. So this is what you can see in terms of X-ray simulation. And if there is a person who is having some COVID-19 or there is a breast cancer based problem, we can just have to input the X-ray and the machine is able to detect the breast cancer, COVID-19. And of course, if there is any problem with regard to smoking and other things, we are able to get all the vitals. And trust me, this accuracy is little bit about 89 to 91%. Lung cancer patients can also be cured with this. So we don't want to stop here. We have also made some AD-based simulators, and you can see the demonstration right now. So here is the trainer that you can see. So this is the complete design that is being conceptualized by me. So it has the pad locator, loudspeaker, display screen, all the functions. And you can see it's an in-house development, and it can perform with all types of modes that you can see in terms of sensor devices, processor, and user interface. But now very soon it will be integrated with artificial intelligence. So these are some of the options that you can see, and this is how you can demonstrate and you can perform. Even in fact, you just have to press one button. It will be SOS to the nearest hospital. So with this, everybody, I hope you have seen that what exactly is the work that is being performed by me and my team, which is actually, you can say, to the next level. But we are working more on medical robotics, gynecology simulator, and of course, I'm having tons of papers in terms of biomedical research, in terms of like cancer-based research. You can all see my publications on ResearchGate, Google Scholar, and Scopus. So now, everybody, I will come to the main lecture in which I'm here. So let us first of all start with the understanding about the IoT. What is the foundation? What are the top technologies that will be growing? And what will be the annual rates? And of course, we are in 2025 now. So what exactly should be your preparation and what should be your focus of research? So you can see that right now, if you talk of the top 5 technologies, it is AI, IoT, social internet, blockchain, and big data. And of course, you will all agree with me that they have not only increased by only 40% or 30%, but they are coming to the next level of percentage improvement. And everything will be based on these technologies. But otherwise, if you talk of automation, robotics, VLSI technologies, cloud computing, smart cities, quantum computing, they will also be integrated. But remember, AI and IoT will be the stepping and foundation stone for everything that you can think of. So what is IoT? IoT is not all about technology. The industry needs energy pills. And what the energy pill is, that we have to integrate, we have to modify, we have to go for exascale improvement at the quantum level, that where the IoT technology or where the sensor and VLSI technology can be integrated. But trust me, right now, defense applications are having limitless use cases that we can perform for IoT, especially when we talk of drones, robotics, and underground technology. So this is the IoT market. You can see that it has already started with 12% increase from 2019, and as per 2024, it has already increased by more than 21%. But that the same increase we will expect from 2025 to 2027, which means that we can even expect a raise of more than 50% in next coming 2 years. So that's the answer, everybody, that this market is now going to explode by about, you can say, $525 billion in the next 3 years. Because why? If you talk of autonomous revolution, if you talk of your AI revolution, if you talk of your industrial automation, integration of quantum technology, all will be based as a foundation stone for IoT market. So IoT market, if you talk of technology by 2022, you can see that if you talk of IoT technology layer, when we talk of applications, platforms, security, communication, IoT devices, everything is actually gaining the market. And you can see that the percentage of increase is more than like 80 to 90%, which is booming year to year percentage wise. So you can see everybody that this is going to be a very important aspect for all of you to understand that more connected devices as compared to the people. Today, remember at one time, person was just only using mobile phone, but today we are using wearable watches, we are having smart home, we are having smart offices, we are having tons and tons of sensors in our television, in our transportation cars. So remember, you can see that if you talk of 2025, the 75.44 billion IoT devices will be installed. So you can see everybody that it has already jumping the number by 40%. So major challenges of IoT market is that developers that are rushing into IoT market is not secure. And that's the answer, everybody, that if you ask me that, sir, I want to do research in IoT, what exactly will be the research that I should focus? The number one research right now is IoT security. Very important. Second is that the system is lacking of data scientists, because IoT devices, like if you talk of LoRaWAN or real-time communication for smart agriculture, cities or industry, we need more data science algorithms to be cluttered, and of course in the middleware that can process tons of data and give us the recommendation, which means that we need data scientists and explainable AI professionals that work together, make up the middleware and give the results. Number 3, attack vulnerabilities. Number 4, firmware updates. And number 5 is more and more reliability in large range communications. That's the reason at one time IoT was limited connectivity. Now we have LoRaWAN, but the future is based on that is called your Zigbee and all those other devices. So everybody, if you talk of the market, we can see that by 2032, this market is going to be more than 1,413 billion US dollars. So that's the answer, everybody, that if you go to Vision Research reports, IoT market is like crazy. And this is the global IoT market. Of course, India is investing into quantum computing. India is investing into defense research. But as per some of the research, that this market growth rate was only 30% by 2023. And by 2024, this was 46%. So this is the data aggregation challenge. This is what you can see, that data today is generated at a exascale level. At one time, it was only like megabyte, gigabyte, terabyte, but now we are moving towards petabyte, we are moving towards exabyte, we are moving towards yottabyte, brontobyte. But when we talk of quantum computing, maybe we will have the quantum bytes. So remember, everybody, if you talk of the data generation, 1.1 billion data points are generated by sensors every day. Now imagine how many people in the world are using Apple watches, and if you integrate all the data for 1 minute, imagine the data that is getting at the end of the Apple servers. 10,000 gigabytes of data is generated by jet engine every 30 minutes. And remember, everybody, if you talk of autonomous revolution, for even 5 kilometers, if you are taking your autonomous car from one point to A point to B point, it is taking about 4 terabyte of data for just 1 kilometer. 90% of the world's data has been generated in last 2 years. And that's the primary advantage, everybody, that still we are not into full big data because the world is not getting all the internet services. But remember, when we talk of this Elon Musk Starlink technology, when he claims that whole world will be connected, but trust me, that is the answer when the IoT age will actually begin to the last level of high potential services. So that's the way, everybody, you should understand that the next level of data science, IoT, cyber security, it still need more research like anything before. So that is the information from the internet, that you can see that as of now, we are working on exabyte, and of course, very soon we will be on yottabyte by 2027, when autonomous revolution and VLSI technology will boom more. But now after 2028, when we expect the quantum computers, we will move towards yottabyte and then brontobyte. But after brontobyte, we have nothing you can say the decimal system that is being coined, but that will be quantum byte, that will be 10 raised to power 91. So this is IoT, everybody. You can see that as compared to the trillion sensor visions, what I'm expecting is that the sensor vision is going to increase by 57% starting from 2025 onwards. And now we are moving towards zettabyte scale by early 2027. So IoT means intelligent interactivity between the things so that we can exchange the value and the knowledge for value creation. So that's the reason today, if you want to integrate IoT, people are not going to depend on telecoms for 5G. They are working on private 5G networks. Today, people want customized cloud computing. They want their own edge computing services. They want their own big data analytics and algorithms to work together. And that's the reason, everybody, today IoT wave is all about customizing, integrating, interoperability, security, and of course, integration. Now, if you are working into any space, imagine what you can bring with IoT and what IoT can bring on the paper. That is what you need to design and you need to research out. So IoT wave, you can see from connecting devices to human value, we have the device connection, the sensitivity, analysis, communication, human value. This all is working and integrated together. And this is where you need to perform your research. Remember, everybody, IoT not only means deploying the sensors and getting them connected to the internet. We have plethora of information that is coming. In fact, the junk or you can say unstructured information is coming. We need to integrate that. That's the reason data analyst and AI jobs are more required in terms to integrate them and to make it more usable in terms of reliability, in terms of quick decision making. So IoT market, you can say that if you talk of 2030, 24.1 billion devices and 34% of the hardware will be IoT compliant. So these are the three tsunamis of internet. At one time, we have the fixed internet, which means when we used to have your broadband services. Today, the era is of mobile internet, and next era, or you can say the era that has already been started from last 6 years, it is IoT. But the next era, everybody, remember, at next era, it is not only the internet. It will not be Web 4.0. It will be quantum internet. Now remember, everybody, even if the quantum computing comes, you need to have the quantum computer to process that particular information. And for that particular information, you need quantum internet and you need the quantum data sets. That's why quantum data sets, quantum internet, and quantum computers will be combined together with advanced quantum artificial algorithms to give you the decisions which will be taking the decisions to the quantum level. So no, I know it little bit complicated, but remember, in terms of tsunami of the internet, the next tsunami, the fourth tsunami, is basically known as the quantum internet or quantum computing based internet technologies. So everybody, if you talk of Internet of Things, we are talking about healthcare today, but in fact, I can give you tons of things that you can imagine when we talk of surveillance, smart cities, connected cars, energy, and of course, your VLSI technology, building technology, agriculture, manufacturing, IIoT, retail sector, everything is getting tons of patents. In fact, ladies and gentlemen, I would like to tell you that today, if you have a good project in terms of automation, in terms of business intelligence, when you are integrating advanced concepts of artificial intelligence, there is a big chance that even if your concept is little bit good, but not highly good, there is a high chance that you can get the project. So right now, what the project I'm doing is that all the business applications were using at one time robotic process automation. Now we want to take those applications to the next level when we integrate LLM models. So if in fact every day you should see that what is OpenAI or Google Gemini or of course Microsoft Phi or Facebook Meta that is going for Llama models, so all these things. But remember, these all models needs to be integrated more towards applications. So that's the reason we are doing the project with Global 30 about $1 million, that how we can integrate LLM models to the next level and we can turn the business applications to be fusing to the next level of intelligence. So these are some of the pivotal moments in terms of IoT. But of course, if you ask of 2025, the next level of 2025 will be completely customized Internet of Everything. So 2025 will not be using the IoT. In fact, this is the last lecture of mine which I'm using IoT, because my next lectures will be only based on Internet of Everything. But the next 2025 will be customized Internet of Everything, when everything will be customized as per your requirements, when everything will be customized as per your industry, as per your business application, industry type, and of course the user requirements and your value addition for the client and the company bridging up. So these are some of the top technologies that you can watch in 2022, or of course it is also already from 2024 in terms of hyper automation. IIoT, 5G is becoming good and good, secure remote access, sustainable technologies, and of course, what we are planning is that we want a customized hyper Internet of Things. So everybody, the Internet of Things is next generation of communication, and 5G will be in next 10 years later. But remember, we are not expecting 5G to be with us for the next 10 years. We are expecting 6G to hit the market by 2031. So which means that day is not very far. So still we can say that it is having the 3 layer of architecture. One is networking, that how you are doing the networking, the connectivity in terms of framework and transportation, and what kind of information can be ported from one point to another point. So in terms of settings, everybody, you can see now this is a point to discuss that what exactly should be your application area. Now in this application area, I'm working on 3 areas. Number 1 is smart cities. Second is healthcare. And we are working very closely for autonomous revolution that you have seen in my projects right now. So smart systems and Internet of Things are driven by the combination of sensors, connectivity, people, and process. So that's the reason, everybody. Now you have to decide what kind of VLSI technology you can bring on the stage. Number 1, how you can integrate with high-end connectivity, and what kind of people and processes you need to integrate, and you can derive the value-driven solutions from that aspect. And these are some of the sensors that you can see, but I can give you tons of sensors to give you a digital nervous word. When we talk of machine vision, acceleration, temperature, humidity, electricity, the VLSI sensor technology, chemical technology, you can use any technology. In fact, every day we are working on healthcare sensors. We are working on that. We are working on smart city sensors. We are working on quantum sensors. So everything is there. Diversification is there. You have to design the lab. And if anybody needs my support for design lab, let me know. And this is the connectivity. We only started with just like a PAN, LAN, and WAN, but now everything is moving towards edge computing, 5G, and we are working on LoRaWAN technology, ZigBee, and of course the future will be DAS7 also. So this is one of the example that you can see right now for communication standards. So I don't suggest that you should work on 3GPP standards. I would like to suggest you to work on non-3GPP standards like ZigBee, long range communications, high security, and of course the better connectivity. And this is what you can see, the communication technologies, which we have already seen from year 2022 onwards: ZigBee, LoRaWAN, NB-IoT, LTE, and 5G. So if you ask the current projects that we are working with, robotics and all those technologies that you have seen at the start of my lab, we are only working on LoRaWAN, 5G, and of course the super fast edge computing services. And these are the people and processes. So we have the patents, we have designed our applications, we have designed for healthcare, we have designed the application for military, we have designed application for doctors, we have designed application for dentists, we have designed application for hospitals. Now it depends that what exactly the application you want to design, but I would like to suggest you that focus more on industrial automation. You can design cyber physical systems, you can work on actuators, you can design smart buildings, you can work on smart grid technology, which is actually most demanding technology right now, because still the smart grid is still theoretical. I have not seen many things doing practically thing in terms of power systems or smart grids in real time. So Vietnam also has the policy that they want to integrate everything on smart grid by 2028, but still many people are required for making this process to the next level. So these are the components of Internet of Things. We have the things, which is sensors, connectivity, which I've already explained to you, the 5G, NB-IoT, LoRaWAN. We have the data, super data that is coming. That is a super imbalanced data, unstructured data. And we need analytics to make this data usable and to transform it for value addition. And why IoT is at the inflection point, you can see hardware is cheap, connectivity is pervasive, very easy development, because today if I want to program any sensor, I just have to give the sensor name and I just have to write something on OpenAI that what kind of coding I need to get it to the sensor and what kind of operation that sensor needs to operate. So the development is becoming easy and easy. In fact, I can generate quantum computing code or quantum circuit code with the black box AI or chat GPT in just matter of 10 seconds. So the Moore laws will not continue, because today if you talk of Moore's law, it says that everything will be doubled in 2 to 3 years. But if you talk of VLSI technology, IoT or AI based improvements, everything is booming within less than 3 to 4 months. So that is the importance of connected assets. You can see that the goods will talk to you. There is a good surveillance, the electricity bill, the smart grids, the smart parking system, smart city level autonomous technology. This is what we can expect in the near future. So this is the understanding phase. That is what you understand and you can deliver some value. And if you really want to do research into IoT or of course IIoT, you need to build this pyramid based architecture, whether it is for robotics or drones. But remember, these components are very important for industrial point of view. So you can see in terms of customers, the tracking things, data management, ad hoc analysis, business intelligence, the deep analysis, insights. And of course, when we talk of the next level of insights, we become wisdom, which means the decision. Now, this is where we are working our level best for healthcare, that how we can make a paperless, a green hospital with smart Internet of Things, where robotics and surgeries can be conducted, and how this level of pyramid can be built for next level of complete supply chain, smart city and smart agriculture 4.0. So this is one of the example that you can see. The paper is already published this year. So that is a smart city based PaaS platform. And you can see we have the sensing layer, we have the communication layer. At that end, we are using only Zigbee, LoRa and NB-IoT. We have the physical layer abstraction in terms of application tool, the third party services. And in terms of IoT platform, we have designed the complete city brain. And the cloud computing services that we are using right now is only Microsoft Azure and Alibaba Cloud. And if you talk of IoT application, it is fully towards security, no cache city, eco-friendly cities, sustainable technology, traffic management, and of course, emergency response services. And this is what we are working on: smart hospitals, remote care systems, mobile client devices, buildings, interconnected clinical information system, the data, and the most important area that we are working is cyber security for the hospitals. Remember, everybody today, even as a computer hacker, in fact, I'm a professional hacker. If anybody wants to discuss with me for cyber security at the end, you can discuss with me. But trust me, what I'm going to give you a big statement right now. In fact, as a hacker and sometimes when I go for real-time forensics and penetration testing, because I'm EC Council certified, so I see that most of the people have security vulnerabilities in the hospital and they have not updated the technology. So what I'm expecting is that the devices and systems that we are integrating today, at least they should be available and they should be non-vulnerable to, that is called your denial of service attack and ransomware attack. So my work is not only to design the systems, not only the intelligence system, but smart and secure intelligence system that is having integration for value addition, value chains. So that is your value point, that even today when I get the papers from different journals like Computer Networks, Communication Systems, IEEE transactions for review, but whenever I see the paper, I don't see anything working in terms of security and sustainability. So whenever you write the paper, whether it's of VLSI, so focus more on your security, the diligence technology, interoperability, and of course, you need to make it sure that you don't violate the things of sustainability. So this is where you can make a complete, you can say, an ecosystem that your research is a valuable research that can be taken to real time. So these are some of the value chains that you can see in terms of module, objects, connectivity, platform, software customization. And needless to say, everybody, we are even competing with the people. We are even competing with industry. I'm competing with Libelium and Vastmodes like these companies. We are also working our own end for device development and interoperability. But remember, still we need many companies more that they can open up the services and they can open up for IoT-based secure optimization network. Now I will be discussing about Internet of Medical Things, and you can see that this is the industry that can even boom up to $150 billion by 2026. And trust me, this is just a theoretical number, but if robotics and automation comes and more AI comes with LLM models for healthcare and more accuracy comes in advanced super intelligence based models for breast cancer or for eyes or kidney and gynecology, this industry can even touch $400 billion by 2030. So what is Internet of Medical Things technologies? Now suppose there is a patient. Now imagine I'm using Apple Watch. So Apple Watch is also taking the regular readings of your body in terms of temperature, pulse, and all those things. So similarly, if you are a patient, you have the wearable technology, which is having the sensors. They are getting all the important readings in the form of data, and they're giving all the readings to the hospital and even to the doctor. And the doctor has a particular front end system in order to make the readings more readable and presentable. And in that presentable readings, the IUMT makes the optimized results for patients, healthcare systems, patient families, and healthcare clinical decision support system. So that's the answer, everybody. If today you want to design a IUMT system, you can even design with 100 rupees also, even with 700 rupees also. But the only thing is that how much accuracy is with your sensor. So that's the reason every sensor in my lab, it is based from Libelium or either from LabVIEW, which is actually very, very expensive. In fact, if you talk of the heart rate sensor that we have integrated with our BIOS and Health 4.0 version, that only heart rate sensor is costing 5,77,000 rupees. So imagine if you want to conduct this type of research, it is not an easy research or cheap research. It requires a high skilled people and requires high end money to conduct the research. So healthcare is benefiting the IoT in terms of remote patient monitoring. As you can see that if you have the integrated Apple Watch or integrated sensors, and this can be done in order to remotely check you. Device to device analytics, we can perform timely equipment updates, firmware updates, and everything becomes secure. But right now what I'm planning is that, in fact, I'm not planning, in fact, we have already done it, that all the data that will be transmitted and all the data that will be secured on the medical server, that will be based on blockchain. So we all know in terms of blockchain technology, we are using the most advanced encryption algorithm, that is SHA-2. So that is still impossible to break unless or until hackers are using quantum computer, which is impossible to use till in next 10 to 12 years. So IoT in healthcare, which means that we have to ever increase the population and we have to bring the lifestyle away from the diseases. But remember, everybody, I don't want to scare you that COVID situation happened, we all know. And we have to think of the next level of situation, that if this type of situation again occurs, are we ready? And that's the reason that today, if you talk of the medical technology, the biggest problem is to understand the disease at an early level, that is a new disease, and to give some antidote. So that's the reason that some of the universities and some people, they have already built up a complete simulation system of a human body. You can do the research. It is already being covered from YouTube under NAS Daily. And that is the most advanced AI system for the human body. Like suppose I'm a person and I want to make some, and I have already designed some medicine for asthma. So I will get that simulation of a human body with the same DNA vitals, and I just take my medical DNA vitals and put it into that particular patient body, which is a virtual patient body, and I can see that what can be the results for asthma medicine. So that is where we can say that if we have the next level of COVID disease, which I hope that there should not be there, I believe in God. So if there is there, then we are ready with this type of technology. So in terms of IUMT solution, you can see that we have the clinical efficiency, consumer home monitoring, fitness variables, infant monitoring, biometric sensors, brain sensors, sleep monitors. Now, I'm 100% sure that today 90% of you who are listening to me, you are using smartwatches. If you are not, please buy it, because we are already in 2025. It is very important that you should take a smartphone to the next level. You should have proper cloud computing with you. You should also use the smart wearable technology. If not, you must use it. So if you're using it, in fact, it is also a IUMT device that is sitting on your wrist, and it is regularly monitoring all your body vitals. So this is the healthcare system in which we have the integration in terms of the medical provider, the doctor, and the patient. And this is where we can say the architecture P brings all things together in terms of provider, pharmaceutical companies, the patients, and of course the policymakers. And that's what we are working together, that in terms of 5 Ps, we also add 5 plus 1, 5P plus 1 be blockchain. So you can do this as a research, that what you can do, that how the data, patient's data, and all this real-time data can be transmitted in a secure medium. So blockchain is the particular answer. And I would like to come to why healthcare IoT. You can see that if you talk of patient engagement model, we are working on patient data from the devices, and that is where we are designing. Now, my next level is to add AI-based intelligence on the device itself. Now remember, if suppose I'm a patient and I have a heart problem and the doctor has given me one sensor that, okay, I want to monitor it. So rather than the heart rate sensor can give the body vitals to the doctor, let the onboard sensor or the onboard neural computing chip, that is the NCC or the NPU unit, can even integrate that data and give the recommendation to the doctor that what exactly is happening and what is my recommendation to you. So that's the reason that VLSI technology with advanced chip engineering should also be integrated with advanced neural network on board, and we can make the decisions in real time. So this is one of the IUMT system. I have already written like 16 to 20 papers in this area, but we are working on hardware, we are working on software, we are working on security, we are working on integration, real-time services, application use cases for different body vitals and different monitoring. You can check my paper for that. And this is what I would like to show you in terms of smart pills, that in the future, if you are really working into this area, then smart and micro robotics with nanoscale technology is very important. Because in the future, we don't have to conduct the surgeries by cutting the body parts and all those things. We can put the smart pill and let the robot comes out and we can perform all that type of nano surgeries with the advanced nanotechnology. This is where many German universities and MIT and Oxford University and UCLA from Australia, they're working day and night on this area. So remember everybody, actually, I don't say that Indian medical research is now like little bit outdated, but it is good. But they have to understand that today modern world is not only with finding the solutions, but also with the upcoming technologies to be integrated. So that's the reason that technology is very important for us to understand when we talk of VLSI technology, healthcare technology, and the body vitals when we talk of the next care of clinical decision support systems. And this I would like to come with one of the system that we have already designed. This is one of the highly cited papers of mine in terms of COVID-19, and this is integrated with IUMT platform. So this is the IoT and IoE based future tech. So that will be based on AI, intelligent things, virtual reality, blockchain, digital platforms, our adaptive security architecture, digital health, big data, and advanced analytics. But even I can take I can add many things in terms of robotics, language models. We can even integrate that is about your swarm drones based intelligence and smart ambulance. So many things can be integrated, but the only thing is you have to find the ways that how you can modernize the hospitals and you can bridge the gap between the patient and the doctor so that early detection and accurate diagnosis can start from the right minute when the patient enters the hospital. So this is one of the example that I would like to give you the demonstration. This is actually you can say a demonstration that you can see. But remember, we have already designed this system, but my system is little bit cheaper and it has more than like 35 sensors. This system is better, but because it is from industry. So see the working system, but now my system that is coming, that will be having artificial intelligence onboard chip, advanced VLSI system, very near future. Maybe there's a problem with the sound here. But anyways, I can show you this one. Maybe you can see in the future. So you can see that you just have to plug in and plug out, and you can select the sensor and just have to connect your body vitals to all the things and it will generate the data. And all the data that will be coming, it will be going directly to the doctor. So that is just monitoring, but my system will be using onboard artificial intelligence to recommend the systems. So the next technology which I would like to show you is basically with NVIDIA Omniverse. This is based on digital twins. I think there is a problem with some sound. So you can see that the doctors are actually performing all these type of digital twin based operations in real time, where the operations can even be, or the things can be reduced before it is coming up. So we have planned to work on this from last year, but very soon we are working with NVIDIA to make up our own Omniverse based lab in 2027. So now everybody, this was all about IoT. Hello. Hello. Madam, can you hear me? Hello. I think there was a problem with some sound with the video at your end.
Sir, we can hear, sir.
Okay, no problem. Okay. So this was all about the foundations of my lab, about IoT, about Internet of Medical Things. Now I come to the last part of my lecture, that will be AI and IoT, a powerful combination, that how they will be influencing the life of the mankind. So welcome to the future, everybody. This is the only thing is that think and only think and find out the solutions what can be performed. So you can see, everybody, that if you talk of digital transformation, it means trillions of connected devices making data, decisions, and giving the directions. And how big is a trillion? It is unknown. So that's the answer, everybody, that if you want to integrate a doctor in the hospital, which is like a cobotic, so machines don't sleep or blink, machines are actually having billions of data points, and of course monitoring the machines need another machines. And that's what we are integrating, that can we make the robotic surgery possible? Yes, it is possible today. Can we make the Omniverse and digital twins possible for healthcare? Yes, it is possible. But the only thing is you have to make the accuracy and efficiency to touch more than 98%. So this is what you can say if you talk of the machine network effect. So it all started with the IoT evolution when we talk of 2007 as connected devices. After that, the products, then product line, process. But 2025, everybody, I have already told you, it will be completely connected ecosystem, which means your combined ecosystem in terms of customized Internet of Things. So artificial intelligence things, everybody, you can see that it is a combination of AI in terms of your cloud computing, edge computing, in terms of language models with IoT, so that we can improve more efficient IoT operations, improve human to machine interactions, and enhance data management. And that's what you can say, that if you really want to integrate it with human capital management, integrate machine to machine frameworks, optimize the system and network operations, that's the reason artificial intelligence of Internet is one of the best things that you can perform. So you can see, everybody, if you talk of this diagram, so we have the IoT applications that are having the data, and now we give that data to artificial intelligence in terms of data collection from IoT. Then we have the big data that is capturing the data, and we will use AI in order to perform database learning and analysis and to keep the recommendations. That's the reason, because the problem is that we have to leverage the decision from massive amounts of data that is coming at a particular point. So remember, if you talk of IoT, there are two types of things when we talk of AI: data at the rest when we talk of data sets. But in terms of IoT and real-time operations, the data is always at the motion. So we have the massive data and the cluttered data in terms of unstructured forms, and we need to perform proper labeling at the real time and give the decision orientations. So that's the AI IoT. So in terms of smart health, smart factory, smart logistics, endpoints that you can see, cloud related services. But the only important thing is that how we can make it better in terms of human machine interaction. And the broad perspectives are in front of you, that AI focused IoT companies are actually dealing with intelligent reasoning and speedy data analysis, and companies need to perform the more powerful subset of artificial intelligence that right now is called machine learning, but the future will be explainable artificial intelligence. And that's a major thing that you need to perform, or you can say you need to research, that trust is the oxygen. Still, the models that we are working is, no doubt they are having trustworthiness, they are having responsibility, but still we need to integrate that how industrial data or the data that will be coming up, how we can make it trustworthy and keep the privacy standards to the next level. And so the future of 2025 onwards will be people-oriented IoT in terms of sensors, in terms of AI, the thinking, suggestion, and sensing. So these are some of the trends that you can see right now: predictive maintenance in terms of autonomous vehicles, the AR and VR technology, brain computing. And I believe in factory automation, cobotic technology, and increased use of digital twins. So remember everybody, at one time, if you are making a product, the product was accurate or non-accurate, it depends. But today with digital twin technology, we can test and validate the products to the next level. So this is the top 10 area of research that you can perform in IoT and IoE. Focus on security, very important. IoT in manufacturing, IIoT, big data, better workforce management, IoT in customer services, and of course, how you can improve the cloud vendors and emergence of smart cities. And now the house is open for the questions, everybody. If you have any question, so please ask me. Here is my mobile number, that is a WhatsApp number, my email, and of course my website. And if you want to follow me on Instagram, most welcome to follow me on Instagram, on ResearchGate, on LinkedIn. Everywhere I'm available, you can connect with me. Thank you so much. Now the house is open for your questions. Most welcome for your questions. Most welcome.
As participants can interact with the speaker.
Yes, Harsha sir, please go ahead.
Harsha sir, your mic is enabled, please.
Sir, good evening, sir.
Yeah, good evening, sir. Good evening, please. Go ahead.
Sir, you have given a nice, what do you say, insights, very clear insights into the practice, to the real-time systems and how, and even you have given the future aspects. That's fine, sir. But a small doubt, people are speaking about DevOps and MLOps, and how this MLOps is integrated into IoT. Can you throw some light on that?
That's a good question, sir. In fact, I would like to tell you, first of all, let me start with DevOps. First of all, I would like to tell you the brief about it. Now, if you are a software engineer, at one time, we can talk about why the software models came, because the software was running into errors and we were not able to achieve the high level of customer satisfaction. That's the reason, if you talk of traditional software programs, we were using waterfall, Scrum, we were using waterfall, prototype, and spiral models. But after that, the theme changed. When we want to integrate customer and to improve the customer satisfaction, we integrated, that is called your Scrum based, or you can say your agile methodologies. But today, everybody, let me tell you what is DevOps. DevOps means that it is a combination of development and operatives. So today, developers, operations, customer operations, they need to be integrated. That's where the DevOps came. Now, if you talk of another concept in the market, it is called MLOps, machine learning operatives. Now, remember everybody, if you talk of the modern artificial intelligence, if you want to do these projects, you have to integrate with the AI, you have to integrate with the data. And that's the reason that today, if you ask me, sir, that I'm having a factory and I want to make the digital twin, how you can integrate this type of digital twin that I can make the modern manufacturing process good, and my products are of high level of trust, responsibility, and of course, in terms of trustworthiness and maintaining privacy sectors. That's the reason today we have to not to integrate agile technologies. If I'm a developer, I will go for DevOps and MLOps, which means developer operations and artificial intelligence based things will be working together with you in terms of high level of software engineering. And then we can integrate the next level of IoT technologies like digital twins, edge computing, cloud computing, big data, cyber security at one particular form, customized with your private 5G networks, and we can deliver the solutions to you. That's my answer.
Will we be able to program to the embedded level also, sir? That means
yes,
the
of course, sir.
points
We are already programming to the embedded level. In fact, today, if you ask me that today many companies are coming to my office that, sir, we want to make this type of machine, sir, we want to integrate LoRaWAN communication. Can we program these type of things? In fact, today everything is so customized, everything is so easy that at one time, if I want to program the temperature sensor with embedded C++, it used to take me about like 30 to 40 lines of code. But today, if you talk of the online cloud-based things, if you talk of Bolt IoT, if you talk of your, you can say, if you talk of your modern systems called Raspberry Pi, if you are a developer, in fact, if you talk of LoRaWAN, I'm not programming on my computer. Everything can be programmed and customized on the cloud itself. Today, the matter is that embedded systems are working and integrated on the cloud. You just have to program and reprogram them. In fact, if you talk of LoRaWAN, it is bidirectional communication. In fact, if today, if you have the sensors and if you tell me today that you are a farmer, sir, please off all the sensors and I want temperature sensor to be only activated at 10 o'clock and 2 p.m. and 7 p.m. So I can just sit on my computer, open the portal and program them. Bi-directional communication. That's the answer. That programming at embedded level is really, really cheap. It is following the next level of intelligence. And of course, we are having highly customizations. That's my answer.
Sir, probably it could be a repetition. Actually, my doubt is when I have deployed a simple model, for identifying something on the AGM and probably ESP32 or Raspberry Pi kind of thing.
Sir, don't go for AGM or Raspberry Pi. That was like a old school technology. If you really want to ask me that, sir, what I should do today, what kind of embedded system I should be using in real time, I only suggest you focus either on BeagleBone or you should use NVIDIA Jetson Nano. That's my answer. So please don't use Raspberry Pi, because Raspberry Pi today, in fact, today many papers come to me that, sir, we are using Raspberry Pi Arduino. Trust me, I don't even see those papers. I reject them. That it's an old school technology. Focus on Jetson Nano, focus on Beagle Black. In fact, you can even use Pine 64. Use that. More customized.
So, sir, let me put it this way. If I'm having Jetson Nano and the field level,
yes,
like can I will I be able to deploy a new model dynamically using ML?
Of course. In fact, sir, right now, if you're talking of our drones and robotics technology, we are only using Jetson Nano. In fact, you have seen my projects. Even in fact, in my drone also, it is Jetson Nano. We are programming that drone on the model or on the sensors remotely, and we are integrating all the data and we are transferring our programming code live on Jetson Nano so that the drone can perform these type of calibrations and perform operations. Object detection, recognition, all the things. No problems at all. Thank you. You are most encouraged to ask me the questions. You are most encouraged to ask the questions, please.
Yeah, good evening, sir.
Yes, good evening, sir. Go ahead, please.
Yeah, I'm Dr. I'm Anil Kumar, sir, from GMRIT.
Okay, sir.
Yeah, actually, we are working on a project, traffic sign identification on autonomous vehicles.
Okay.
Yeah, and using Jetson Nano only, sir.
Okay.
And what problem we are facing in this is the compatible packages while installing the compiling packages like TensorFlow, like that for machine learning. So the algorithm, whatever it to be, we are taking from the net and we are customizing it. It is not supporting fully, sir.
Okay.
So is there any dump like OS supported to Jetson Nano dump along with all these packages? Can you suggest any source for this one, sir?
Okay, sir. Just a second. Sir, can you see my screen?
Yes, sir.
Yes, sir. Can you see this stack, please?
Yes, sir. Yes, sir.
Yes, sir. Actually, what you are using is actually the little bit old technology. So what I'm suggesting you that first of all, you can work on these type of Jetson Nano that is based on Xavier or basically based on AGX. These type of technologies are very good because they will not, because the old Jetson Nano will not be supporting you. Now, if you go to software, sir, then there is a single unified embedded software stack, which is based on NVIDIA Metropolis. So this is the answer for you.
Yeah, we have purchased NVIDIA Nano and Orion also, sir. So
Orion is okay, but the Metropolis you have to work in order to perform more on autonomous vehicles.
Yeah, okay, sir.
The Metropolis is the answer. Okay. Metropolis, yes. If you need any problem, I can support you remotely, no problem. So Metropolis is the answer. You can see if you are really working on autonomous vehicles and everything, you can work on the computer vision, and all these APIs are well integrated for that.
Okay, sir. Okay, thank you.
This is the answer. Metropolis you need to integrate, but make sure that you are using the latest Jetson Nano. So if you just type NVIDIA Jetson Nano developer kit, that is 2024. You can see this one, sir. Yeah, this one. You have to go for the latest Jetson Nano with at least with Xavier platform. Xavier.
Yes, sir. Yes, sir.
Yeah, that's my answer.
Yeah. Thank you, sir.
Yeah, sure. Metropolis is the answer for you. Yes, any other question? Most welcome.
Can you share one or two use cases and the related hardware that how people are using for drone-based UAV applications, whether it is for maybe sensing or for communication? What was the typical hardware they are using on UAVs?
Okay, sir. Sir, can you see this website called Drone Kit?
Yes,
hello, can you see my screen, sir? This is your answer. This is your answer. First of all, you can go to Drone Kit. This is the answer if you want to go for the real-time platform for intelligent path planning, autonomous flight. If you want to go for Python API, this is the best answer. People don't use it. In fact, this platform is little bit open source. You understand, sir? This is the answer.
Yes, sir.
So number one is this one. And of course, if you are asking me that you can even go for this one also, UAV Hub. But if you talk of the drones that you can see, then you can go for this one. That is the drone. At least I can give you this one called the drone FPV. It from. Okay, let me see if I can give you this one. Sir, can you see these kits? Yes or no?
Yes, sir. Yes, sir.
Yes, sir. This is the answer for you. High-tech XYZ, you can see that if you really want to go for like a customized quadcopter, you want to customize for a flight controller, everything is available on this website. So if you see, so you can even see the controllers, you can even see everything, but you can even see that the cost of the kits are between like 13,000 rupees to 45,000 rupees. So I'm giving you this website right now on your chat box.
Yes, sir.
I think chat box is not available for me. Can you see this? Sir, can you see the website? hightechxyz.in. Yes or no?
Yeah, we could see, sir.
Yes, sir. So if you go to drone services, you can even consult with them. In fact, if you go to drone kit and you can just go to hexacopter, you can see the kits like this. In fact, you can go for a kit like 38,000 rupees kit or even like a 45,000 rupees kit. So that is a kit that you can work. In fact, they also have the softwares also. Okay. So similarly, you can even go for tools and you can even go for RC plane kit. You can click here and you can see the complete planes kit is also available for you. So if you want to make a good drones lab or if you want to make a IoT compatible like a drone based modeling kit for research, this is the answer, hightechxyz.in. This is your answer. Hello.
Yes, sir. Yes, sir. Even this
Yes, sir.
supports 4G communication
Everything,
stuff.
sir. Everything. 4G, 5G, whatever you want to have. In fact, they also give you the complete DJI drones that are also customizable.
Thank you, sir.
Yes, sir. You can even see that this one, a complete RC plane kit is costing like 8,500 rupees. Nobody knows that still the drone kit is so cheaper. Many people see that it is like 40,000 or 80,000, but I give you the best medium. So Hightech XYZ is one of the website, and I give you one more website. This is this is called this one, robo.in. Nobody knows that this is one of the best websites that you can even talk to them. In fact, PIC-SOC and Quad QX95 models are also available on this website. In fact, in my lab, whatever the lab you have seen of my drones lab, 90% of my drones equipments are purchased from this website only, robo.in. This is the answer. Got it, sir?
Sir, is it possible to visit your lab in any way?
Of course, most welcome, sir. Most welcome. You can see right now the mini racing drone is available for only 7,500 rupees. The cheap drone kit, which is actually customized, you can even design as per your own applications. software, everything is available. Everything. Got it, sir?
Yes, sir. Thank you, sir.
Yeah, robo.in and hightechxyz.in. Everything is available. You can order depending on the budgets.
Yes.
Yes. Any other question?
Sir, can you suggest any suppose drone technology, delivery drones? For delivery drones,
Sir,
can you
delivery
suggest
drone
any
right now, if delivery drone, sir, I understand, sir. Delivery drone right now, if you want to go for your customization, we don't suggest it because still it is very complicated to lift up the motors and everything. So I suggest you that first of all, you go to a DJI showroom, which right now in India, I don't know whether it is available in Navi Mumbai or Delhi. But if you talk of DJI drone, the biggest drone center, it is in Shenzhen, China, or it is in Singapore or Hong Kong. So visit them. Then you can see what kind of delivery drones they have. In fact, if you go to Shenzhen, now let me show you this market. Let me show you. In fact, you can see this one. I think you can go to YouTube. Let me show you something. Please mute yourself, everybody. Sir, can you see this one? The Shenzhen technology market? Yes or no? This one. Can you see this, sir? Sir, the world's biggest electronic market is here. Now, if you see Shenzhen technology market drones, you can visit these type of videos and you can see that what kind of available in these markets. In fact, these markets will tell you about the customization and all those things.
My friend have a startup in Vizag, sir. Recently, they visited the China and they brought
China. That is the Huchong Bay, sir. Huchong Bay. Yeah. That is in Shenzhen. Yeah. So you can go with them to Shenzhen one time. In fact, above all, you can visit this. That is called your Canton Fair. And if you just say Canton Fair drones, you can even visit these type of things. What exactly is happening at Canton Fair? So visit them. And this is the fair that you must go, that if you want specific drones for agriculture, for industry, everything is coming to Canton Fair. So go to that website, register yourself. It is free of cost. You have to apply for the visa, but we all know we are Indian passport holders, so we all know what can happen. You understand that?
Yeah, thank you very much, sir. You have so much. You have given so much insights about the drone technology at all, and we have a drone lab.
In fact, sir, I am a drone pilot.
GMR.
Sir, I am a full-fledged drone pilot. I am having my drone lab, and in fact, if you talk of, let me show you. I don't know whether you have identified me or not. If you just go to Google, if you just go to Google. So if you type over here, Internet of Drone Things. So you can see, sir, this is my first paper which was written. In fact, the concept of Internet of Drone Things was invented by me. I'm the inventor of this concept, IODT. You were talking to the inventor.
Super, sir. Congratulations, sir.
Thank you. In fact, I'm also I'm going to invent the next terminology, which is already under the progress, Internet of Swarm Drone Things. Actually, I'm the inventor for these things, actually. Any other question?
Yes, sir. Good evening.
Good evening.
Am I audible, sir?
Yes, loud and clear. Loud and clear.
I need to know related to the swarm technology. Is it available with you, sir?
Can you please repeat it, please?
Swarm technologies.
Yes, of course, we are having the swarm technology that is available. And if you ask me, let me share the screen again.
Yes, sir.
Now, if you talk over here, madam, that is called the drone swarm. Now, 90% people don't know that this is also, there is a company called Drone Blocks. Now, if you really want to make your own drone swarm, this is also the package kit that is available. And you can see that this package kit is costing $7,500. Only one company is making this one, that is called the Drone Blocks. Nobody knows about it, in fact. You can see it will give you the 10 drones, chargers, battery, propeller kits, tripod, base stations, and this is the kit that you will see. This is the kit. I hope you can see, madam. Yes or no?
Yes, sir.
Yeah, that is the ultimate DIY drone, your own lighting kit. So you can, if you have the budget of $7,500, you can have. I have already given the requisition to the university. They will give me next year.
Okay.
Yeah, most of the people don't know about it. So you can go for this. And in fact, I can give you one more, this one also, that is called the drone show software. 90% people, they also don't have that. If you really want to go your own startups and all those things, this is actually the company that is giving you your own drone, that how you can program your own drone shows and simulate those drone shows.
Yeah.
Now there is a simulator also that is called Drone Sim.
Oh.
Now, this is the answer, madam. The best simulator
Okay.
is this one, the FPV simulator. Let me show you this one. Let me show you. Yeah, so you can see that. No, just wait. Yeah, can you see, madam, MATLAB also?
Yes,
What
yes,
is drone
yes,
sim?
sir.
So, madam, in
Yes.
MATLAB, you can even see that there is a drone simulation parameter, and you can even go for swarm drones here. Nobody knows that in MATLAB, you can even have the highly fidelity drone simulations, and you can see the drone simulations also. In fact, you can even tune your test path planning algorithms also. You can see right now, programming code is also available. Nobody knows about it, in fact. Can you see, madam, the coding, everything?
Yes, 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 sir. Yes, sir.
Yeah, so in MATLAB also you can go for UAV. In fact, you can go for Simulink based models that are already available. So if you ask me that today, that sir, how we can download MATLAB, you can go to this website called kickastorrents.to, and after that, everybody, you can download anything. So if I just say MATLAB and press enter, you can even see the MATLAB based courses, MATLAB everything. In fact, the PC software of 2023B, you can available for download. It is available free of cost. Everything is available permanently. Okay, madam. Now, if
Okay,
you just
thank you,
type
thank
over
you.
here, now let me show you something. It's going to blow your mind. So if you type over here drones also, so you can see that complete manuals, and if you want to go for some simulators, and if you want to go for some ebooks and all those things, these are all available with this one. This is a completely big website in the world that you can download anything with regard to everything.
Okay.
Okay.
Sir, one more thing. You can
Yes.
send the mail ID, sir.
Yeah, of course, madam, I am not able to write anything on the chat box. My chat box is disabled. I can say that. And, coordinator, please, can you do something for this?
Yeah, sir. We will enable now. We'll.
Just wait. I just opened the notepad. Madam, at least you should see that the chat box should be enabled. I can say that. Okay, no problem.
Yes, sir. anandnair.com.
Just wait, sir. I'm giving you all the things. You can take the photo for this one.
Yeah.
I hope you
Okay,
can
thank
see
you.
the notepad.
Yes, sir.
This is my email ID, everybody. Personal email ID. And this is my official email ID. So this is my WhatsApp number. Anytime you are welcome to give me a call on WhatsApp only.
Sir, it is not visible, sir. Just to zoom up.
Yes.
Visible, sir. Visible.
Madam, can you please open the chat box for me? Hello.
Yes, sir.
Can you see this, sir?
Yes, sir. Yes, sir.
In fact, everybody, you can just go to Google. Just go to Google and you can type my name here. In fact, my name is my search. So you can see my scholar. You can see my ResearchGate. You can see right now I'm completing my almost around 17,000 citations with H-index of almost 70. Yes, any other question? Any other question? Okay.
No, sir, from my side.
Yes, coordinator, you can please take over. Thank you.
Yes, sir. Yes, sir. Thank you very much for this wonderful session, sir. So really, we feel privileged to have you today with us. So thank you very much, sir.
Thank you. Thank you.
Sudhakar, sir, you can give your concluding remarks of the session. Hello. Hello, Dr. Sudhakar, sir is available here. Okay, thank you very much, sir.
Thank you, ma'am. Thank you.
Thank you.
Okay.
Thank you, sir.
Godspeed you
Thank
all
you.
and wish you all the best.
You can share your mail ID, sir.
Can you see the mail ID, sir?
Yeah, wait a minute, sir. Wait just a minute.
Sure, sure, sure. Done, sir?
Thank you, sir. Thank you.
Thank you.
Thank you so much, sir.
Thank you. Thank you.
Thank you, sir. Thank you, sir.
Thank you. Thank you.
Ma'am, I'm audible. Hello?
Yes, sir.
Ma'am, actually, good evening, sir. Good evening, sir. It is actually indeed a privilege to deliver the vote of thanks on this insightful session on the Internet of Medical Things and Artificial Intelligence-oriented medical technologies on the occasion of 60th ATAL FDP program. On behalf of everyone present here, I extend our heartfelt gratitude to our distinguished speaker, Dr. Anand Nayyar, for sharing their expertise and invaluable perspectives on this transformative topic. Sir, today you have illuminated us how the technology and medicine are converging to redefine healthcare and the innovative use of IoMTA combined with AI and how the new horizons for remote patient monitoring, precision diagnostics, and even the predictive healthcare systems. Whatever the labs we have shown, like the state-of-the-art lab facilities, the targeting healthcare, the underground robotics, smart intelligence robots, IoT and intelligent system labs, and we are very much excited to see them. And also about RV plan, DTO ventilator, DTO went to 2.0 and 3.0 with advanced pump volumes. Also, you have given very valuable the advancements which are going to take place in the future and the research areas like IoT security, cyber security, the firmware development and all. And also the exponential growth of IoT, LLM models to the next level of intelligence, hyper automations, the diagnosing any disease at an early stage and providing the antidotes, the neural computing chip uses, smart pills, nanosurgeries, and NVIDIA Omniverse, the machine network effects, and many things. And we are grateful to you, sir, for this valuable lecture. The examples and the insights you shared not only showcased the current advancements, but also underscored the immense potential these technologies hold in improving patient outcomes, reducing healthcare disparities, and making medical services more efficient, accessible. And your ability to break down the complex concepts and convey the practical applications has ignited our minds to have some thought process to take up the research areas. Thank you, sir. Thank you very much.
Okay, thank you, sir. We will move to the last session of this ATAL FDP. So, Govindrao, sir. Hello, Govindrao, sir. Anil, sir, please check out GR Locherla 09. Hello.
Yes, ma'am. Yes, ma'am.
Sir, join Ayera.
Yes, ma'am.
Hello, Govindrao, sir.
Yeah, yes, ma'am. Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Sir, we welcome you for this ATAL FDP, sir, for the last session of this 6-day program.
Thank you, ma'am.
Oh.
Thanks for
Dr.
that.
Shanmati ma'am, you can introduce the guests to the participants.
Yes, ma'am. Thank you, ma'am. Good evening, all. Good evening, sir.
Yeah, good
It's my
evening.
pleasure to welcome Dr. Govindrav, sir, who has 4 years experience as research scholar and 3 years experience in industrial VLSI design and 13 years experience in teaching area. And sir's technical skills extend from RTL coding, behavioral modeling, functional verification, and simulator synthetic tools, FPGA tools, and other operating systems. And sir has a editing vision in GVIM, and other technical skills includes algorithm to architecture mapping and documentation. And sir has completed his PhD from the Department of Electronics and Communication Engineering from NIT Rourkela, Odisha. And sir's publication extends from 4 international journals with the 3 conference proceedings. And the greatest achievements are sir has won first prize in Altera Neos 2 design contest in 2006 and attended the SOP CW 2006 conference conducted by Altra in Bangalore and stood school first and in Andhra Pradesh. And his projects includes 5G NR LDPC decoder. Second one is Radix 8 modified booth fixed with signed multipliers with error compensation, and other projects which are variable length mixed Radix MDC, FFT or IFFT processor for MIMO and OFDM applications. DisplayPort IP verification, 10 GMAC IP verification support, design and implementation of 12C slave bus model, verification of IEEE 802.3 Ethernet MAC in half duplex mode, FPGA implementation of a software-defined AM radio receiver. I welcome you, sir. Please continue the session.
Yeah, yes, ma'am. Thanks for the intro. Let me. Is this camera mandatory? Hello, am I audible?
Yes, sir.
Okay.
Presentation is visible.
Okay, fine. Yeah, thanks for gathering here to share the knowledge on full custom, semi-custom, and FPGA implementation flows and a few of the design practices. Yeah, we are going to talk about these areas. We'll be starting with the introduction to the SOC architecture, system on chip architecture. So there will get to know how the IC complexity is nowadays, and from there, okay, we'll be moved to how actually various kinds of digital ICs are implemented. So of course, most of the audience might have been very much familiar with these implementation flows, but my intention here is to bring this topic is that to connect some of the dots. Probably all may not have connected so far, or if I missed connecting any dots, I may get inputs from you, learnings from you. So that is the thought behind bringing this topic here. And from there, we'll move to classification of the digital ICs and their implementation flows. If time permits, we'll talk about RTL coding styles and implementation of state machine coding styles and a few of other design techniques. So this is the agenda of this session. Yeah. To start with the IC complexity, nowadays the ICs are so much heterogeneous, and most of the gadgets are having the system on chips. Entire system is integrated into a single chip. So those can be analog blocks and sensors and memories, embedded blocks, and buses to connect various IPs inside the chip. So the chip itself will have the processor, peripherals, memory, whatnot for different applications like consumer electronics, medical, automotive, and industry sectors, industrial electronics area. Yeah, to gain the little interest, I have picked one SOC which is related to the smartphone. So that looks like this. This is composed of various blocks like cellular baseband processor, application processor, Bluetooth, wireless, and all these peripheral blocks. And here there is a transceiver block which transmits the signals, and the baseband processor collects these signals and interacts with the OS and the process the audio, video, and data signals, and yeah, to receive the signals through various protocols like Bluetooth, wireless LAN, and GPS. The respective IPs will help this baseband processor to collect this data and to coordinate and yeah, so and yeah, if that is the receiving data and those are processed and finally the signals will be given to the speaker, display port, and like that. And transmission side also happens in other direction. So here, if you see, every block is composed of a microcontroller, almost a CPU and peripherals, RAM, ROM, and stuff. And here, application processor handles all our user apps. Okay, and this Bluetooth block handles the Bluetooth data and wireless, this Wi-Fi data, wireless block, similarly GPS block. And each block is composed of a CPU that is typically, in most of the cases, the ARM processors and RAM ROM and a couple of peripherals and bus connected across that. So these buses are mixed kind of AHB, AHB, and APB based buses. In some SOCs that can be PCI Express. Yeah, so how this is how the system on chip looks like. So this whole together is a single chip solution. On the right hand side, we can see the ARM processors involved in the Snapdragon processor. So one of the distributes this premier processor where you can see how many ARM processors are involved. Even we are seeing
Sir,
in this
excuse me, sir.
block diagram. Yeah.
No,
Yes.
sir. That slide has not changed.
I
In the
mean,
first slide.
no, no. Are you not seeing the block diagram?
No, sir. No, sir.
Body of the smartphone.
No, no. First the title slide. Title slide is only visible.
Oh, okay.
Now it is changing.
Is it? How come what? Are you seeing this overview?
Overview is visible now.
Then what about this? Body of the smartphone SAC. Is it visible?
No, sir. No, no, no.
The next one? Are
No,
processor
sir.
used in smart overview?
Only overview is visible.
How come, ma'am? I'm just navigating through. That is the next slide only. Introduction slide, is it visible?
Second slide overview is visible now.
Give me a minute. Let me fix it.
Now introduction is visible, sir. Third slide.
What about this, ma'am? Body of the smartphone? Again, not
Yes,
visible?
sir. Yes, sir. Now it is changing. Yeah, yeah.
Okay. I don't know. Maybe data speed is limited in your room. It is good. I'm surprising.
Sir,
So
once
I'm
try the presentation mode, sir.
presentation
So
mode.
once
It
try
is
with
in
full screen mode, sir. Presentation
Oh,
mode.
full screen.
No, sir.
Okay.
Otherwise, direct to screen
So
side, sir.
presentation.
Not window. Yes, sir.
Show presentation you mean to say?
Yes, sir.
Yes,
Yes,
sir.
sir.
Sir. Full screen mode.
Is it okay now?
No, sir. Entire PPT PowerPoint is displaying, sir. The options and all.
Okay, okay. 1 minute. Let me stop sharing and share it again. And complete
Better
window.
total screen share is the option, sir. Entire screen. Yes, sir.
Entire screen. That's what I did so far. Okay.
Yes, sir. Entire screen is visible, sir.
Now is it
presentation
visible?
mode, sir. Yes,
Yes,
perfectly
sir. Yes,
audible,
sir.
sir.
Now it is.
Oh, okay. Sorry for the trouble. Fine. Actually, I did that, but later I didn't. I have to select that particular window, and again I have to click share. Without selecting that, it is missed. Fine. I hope I need not to repeat. Yeah. So this is the overview. So we are going to organize this session like this. Introduction to the SOC architecture, classification of ICs, and full custom, semi-custom, and FPGA implementation flows, RTL coding techniques, and that related state machine coding styles, and some other design techniques related to synchronous and asynchronous reset implementations. And then next we had talk about how the nowadays ICs are complex, which involves the memories, reset peripherals, analog parts, and interconnected buses. And then we move to body of the smartphone, which is composed of many blocks. Each one is a subsystem again. So for example, this is application processor, which holds the handles the user apps, and the cellular baseband processor, baseband block handles the transceiving data, video and audio, and this works in coordination with these peripherals, Bluetooth, wireless LAN, GPS, etc. And from this, we can understand there are many RISC processors involved here, and many subsystems, in fact, are integrated together. And on the right-hand side, a Snapdragon processor is how the Snapdragon relates RISC processor using the ARM processors is shown. And from this, we can understand the complexity of the circuit integration. So now let us see what are the various ways of implementing a circuit, and in fact, full custom part, semi-custom part, and a few FPGAs may also involved in a system at the system level. Okay, so this slide is also depicting, illustrating the usage of various processors inside the smartphone. And this is for this is the apps processor. This is for touchscreen and sensor hub, and this is for camera. This is for power management and flash controller, Bluetooth, SIM, Wi-Fi, etc. So it's actually a system on chip involves so many processors for different applications. Yeah, it is quite surprising once switching from this SOC level architecture to a transistor. Here, my intention is to move from very familiar thing towards little more complex things, which may not be really complex what we are going to discuss, but to have a smart, soft transition. Yeah. So this is the MOSFET used in CMOS circuits, and we know operating modes of this MOSFET, which can be operated in 3 operating regions: cutoff, linear, and saturation. Which is linear, we can also call as the ohmic region. So I need not here once again repeat under what conditions we can operate this transistor in one of these 3 operating regions. So you are equally or more experts than me to understand this. And here my point to share is what modes of the transistor are used by the digital circuits, and what modes of the transistors are used by the analog circuits. So digital circuits uses the transistor in either on state or off state, at no time in the ohmic state. Analog circuits operates in the ohmic states. To operate those transistors in those respective operating modes, we have to do the biasing. So all that stuff you know. Yeah. So here we are purely talking about the digital circuits. Then digital circuits can be classified into full custom circuits, semi-custom circuits. Here my circuit is integrated circuit, that is IC. So let me change my terminology. The digital ICs are classified into full custom ICs, semi-custom ICs, and programmable ICs. Okay, again, in the programmable ICs, you know, PLDs, EPLDs, and FPGAs. We are in the FPGAs era. Okay, so let us now at least recap what are the different implementation methodologies in each of these type of implementations. Let us start with the full custom ASIC implementation flow. Yeah. So integration in the sense, integration of crores of the transistors into very tiny area. Okay, so then are we defining our circuit at transistor level? Then you can imagine how complex it is to design a circuit by a human, which is composed of crores of the transistors. That is quite impossible. But all the ICs are not full custom ICs, but a kind of memories. We know the memory cell. By replicating that memory cell many times, we can get even terabytes of the data, terabytes of the memory. So design effort is for one cell and then the replication. So for such kind of applications, we adopt the full customized implementation flow. This flow looks like this. We start with, of course, we have to use the EDA tools to have these circuits implemented. Okay, to that EDA tools we have to enter our design entries, and from there we have to navigate to finally generate the graphic database system, that is GDS information exchange file, which is actually to be shared with the fab which fabricates the ICs. So in the full custom IC implementation flow, we start with the schematic entry. Schematic entry on the right hand side, you can see a simple inverter circuit. So we have to manually draw it. Of course, the symbols and all utilities will be there. We have to simply drag and connect the things according to our requirements. Okay, and that is the schematic capture and circuit simulation. The next stage is circuit simulation. So after entering the circuit, after drawing our own circuit, so we have to ensure its functionality, whether its functionality is obeying or not. So then we have to develop the, don't worry, in the next slide, we'll go in detail about each phase. Then that will be converted into the layout. We'll see what is the layout, and after on right hand side you can see the layout how it looks like. And then we have to do the physical verification and we have to do the parasitic extraction. We'll understand in the forthcoming slides why and why you have to do this. And then post layout simulations. So finally that circuit in the form of GDS file will share with the fab. So here the point you have to notice, we are giving our design at transistor level. So this is possible for small scale circuits at the design level. And in the schematic capture phase, we are talking here. It is a 2-input NAND gate, the CMOS circuits. On the downside, there are 2 transistors connected in series, which are N MOSFETs, and on the upper side, 2 transistors are connected to the power VDD, which are P MOSFETs, and this pull-up segment is complement to the pull-down segment. This series of 2 transistors portion is called the pull-down segment. So this helps in the output node to give to source 0. And in the upper part of the circuit, what I'm showing here is the pull-up, this parallel combination of these 2 MOSFETs is the pull-up segment, okay, or pull-up network. So here this helps the output to source 1. So when pull-up source is connected to the VDD, then output node will be connected to VDD through this pull-up segment. By that time, the pull-down segment path will be open circuited. Here you can see when the input is A, 1 and 0, the pull-down transistors are connected in series. So one of the transistor which is receiving 0 because its threshold voltage is not enough to accumulate the electrons in the channel. Therefore, this transistor will be switched off. These 2 switches are connected in series, so one of which is switched off. Therefore, this output node to ground connection will be open circuited. By the time one of these 2 transistors are connected in parallel, so one of which is receiving 0 as the input, since it is PMOS, this will be turned on, and this helps this output node Y to the VDD. So in this way it operates, and why CMOS you can understand by the way we are connecting these transistors, and by their nature those are complement to each other. If the pull down is NMOS and pull up is PMOS. If pull down transistors are connected in series and pull up transistors are connected in parallel. So here the point is, this is in this way we have to draw the circuit. There in the tool, for example, in case of Cadence, which is a schematic editor, Okay, that is called a schematic entry. So every of the input combinations I did not explain here. So this is also for other input combination how the NAND gate behaves. So when the output is 0 in the pull down segment, both the transistors are on, so that output is connected to the ground, therefore the output is 0. In the earlier case, the output is connected to VDD, therefore the output is 1. So, and it is the inverter. Here pull down segment is composed of one transistor and pull up segment is composed of only one transistor. So this is the schematic circuit design phase, and we have to design the circuit like this, and then same we have to try in the schematic editor. And upon doing that, we have to see whether the expected behavior is behavior we are obtaining or not. We have to verify. So that for that we have to do the circuit simulation. While doing the circuit simulation, your screen looks like this. That output waveforms, input and output waveforms, and circuit entry symbols, etc. And then circuit layout. So what is layout? Layout. So we may sometimes scratch our head at initial stage, but here the layout is this, which is the top view of actual silicon on the chip. Okay, layout is nothing but top view of actual silicon on the chip. So for example, inverter is taken here. So NMOS and PMOS are, you can see in this, this is the NMOS, and yeah, one is NMOS and another one is PMOS. Both the gates are connected here, and from here actually we apply the input, and from both the from other two nodes, the output connection is given. Okay, and here I could say. Here both the drains are connected, from their output is tapped here. So this top view means when we are looking at this physical construction from the top, so that looks like this. So this is called layout. So when we are drawing the layout for this inverter, we need not think about all the physical construction, but it is enough to be skilled in how to draw these poly, metal and transistors, and how to connect these things, and how to connect these to VDD and the ground. So this only will process. So what are all the steps we see in this flow? In this flow, will process on this layout only. So we are evolved to layout from the initial circuit entry. So at that stage also we have to ensure whether this layout is schematic or not. So this is called layouts versus schematic. It is a kind of equivalence checking. Okay, so then we also have to do the DRC, design rules check. So here whether width of each metal or poly is manufacturable or not. Similarly, the spacings between two metals or poly or metal are manufacturable or not, or contacts are obeying the perfect dimensions, allowable dimensions or not. So this is all talks about the manufacturability design rules. Whether properly connected or not is one thing, or and whether the